by low density polyethylene, 10 to 15% by high density polyethylene, and the remaining are the others. The primary reason for this, because after recycling, low density polyethylene does not hold a lot of values. So it's better to repurpose it in the infrastructure sector, particularly in road construction. Previous studies have also shown that when the waste plastics are used in the road construction, there are the positive results. So there are the two methods of using waste plastic in road construction. The first one is the dry process, which we already have the standard IRC SP98 2019, and again for the wet process, due to its complexities, this method is not explored a lot, specifically in the field applications. Coming to the research significance, from the previous research studies, it has been constantly reported that with the wet process, there are several performance parameters which shows a significant improvement. However, there were few studies also which shows the contradictory result. The primary reason for this, with the variation in the sources of the plastic, the performance of the bituminous mixes and the binders vary significantly. Because wet process involves complex chemical interactions between the bitumen and plastic, thus it becomes extremely important to address the source susceptibility of the plastics. So the current research objectives are the first, the quantification of different sources of waste plastic. Again, the second part is to evaluate the mechanical effect of these sources on the mechanical performance of asphalt mixes. Previous studies have primarily focused on the evaluating the rheological performance of binders. And at the end, the performance of these mixes were compared with those prepared with the conventional binders, that is VG30, VG40, virgin binders, and conventional modified binders, that is PMBs and CRMBs. This is the research methodology which is adopted in the studies. A plastic from 4 different sources have been used. All of these plastic sources, all of these 4 plastic sources are procured from the different locations, and also these have they are used as different products and different materials prior to their recycling. When these plastic sources are quantified in terms of the intrinsic polymer properties, we have found out that only melt flow index and degree of crystallinity are 2 parameters which show significant variation with the variation in the sources of plastics. The primary question why this variation occurs, although all the plastics are LDP, here is the answer. Like when we have done the FTIR spectra, we have found out that due to different processing technique, due to different exposure to climatic conditions and pollutants, the chemical structure of these plastics have also changed. Again, with the modification of binder is done using all these 3 plastics, and it has been observed, the optimization of doses is done based on the storage stability test. And it has been observed that with the variation in the sources of plastic, the optimum dosage also varies, and also the mixing time. Although here the 3%, a constant dosage of 3% is selected, and a mixing time of 120 minutes. So both of these doses and mixing time is optimized based on the storage stability and dispersion criteria. After this, for the modified binder, the FTIR spectra has been done, and it has been found out that the modified binders also shows different chemical interactions with the different sources of plastics. Another key finding of this study that involves that when the OBC of the mixes are evaluated, primarily granite gneiss aggregates are used for the mechanical performance throughout this study. But it has been observed that there is a reduction in OBC. Then this claim is further verified by using another source of aggregate. A similar result has been observed, although the magnitude differs, but the trend remains similar. When the performance evaluation of these mixes has been done, it has been observed that plastic modified bitumen was found stiffer as compared to other mixes, irrespective of testing temperatures. It has higher tensile strength, higher TSR values, and also the Hamburg wheel tracking test results shows that it has higher resistance to rutting. Again, for the ITFT test results, it has been observed that 2 plastic sources have shown higher number of cycles to failure, whereas another 2 sources, okay sir, just wrapping up. Another 2 sources shows a lower fatigue life. Coming to the conclusion that to quantify the LDP source, we have to go with MFI and DOC. OBC reduction is observed with the plastic source, and again MFI shows direct correlation with the fatigue life of binder, whereas for the at higher temperature, both MFI and DOC governs the performance of bituminous mixes. Coming to the way forward, like first we have to develop a criteria for the plastic selection to effectively select the plastic which is suitable for bitumen modification. And for this we have to develop the MSMEs. Which will provide us the plastic which is suitable for binder modification. Again, we have to figure it out where to modify the binder. Either we have to go for on-site production like the CRMBs, or the plant production like for the polymer modified bitumen. And at the end, we have to construct some test section and evaluate its long-term performance to evaluate the effectiveness of this approach. Thank you very much. That's
This way forward is for whom? This way forward is who will do it?
Sir?
The way forward is for whom?
Sir,
Who will do it?
sir, future scope. That is for the
So you should write future scope of the work. Way forward means anybody's game, whether PWD or any, MIT, USA, or Stanford University or IIT, BHU. I mean something, usually we write future scope of the work. But future scope of the work also should not be Mahabharata. कि आपने इतना काम किया है, आपने बोल रहा है इतना करो, तो फिर आपने क्या किया है? ये भी होना चाहिए ना. People write it like, future scope of the work. So you have to be very precise. Then आपने क्या किया है उस पे? मैंने कुछ करके बोल दिया कि बाकी सब लोग वो करेंगे. ऐसे नहीं होता है. You have to be very specific. ठीक है, Akash, thank you very much. Your presentation was good. Now last one, a comparative analysis of laboratory compaction techniques for simulating field compaction of granular subbase. Very important. GSB by Sri Suranjit Saha, Research Scholars, IIT Madras. So Suranjit, Madras is not very far off from Bhubaneswar. So can you finish it in 4 minutes?
I'll try my level best. Good afternoon to all the respected dignitaries and delegates present on and off the dais. I am Suranjit Shah, PhD Research Scholar from IIT Madras. My supervisor is Dr. Surinder Singh and co-supervisor Dr. Ramesh Kannan Kandasamy. Today my topic of presentation will be comparative investigation between the different laboratory techniques to simulate the field compaction of GSB. So in field, different types of rollers are used to simulate the field compaction, which uses compaction mechanisms like impact, pressure, vibration kneading, or combination of any one or more of them. However, in the lab, we use Proctor or modified Proctor, which uses impact type of compaction mechanism, which either overestimates or underestimates as compared to the field compaction. So for GSB, it acts as a load distribution layer as well as a drainage layer. So load distribution is related to the amount of interlocking, which in turn is also related to the texture, angularity, and the packing density. And for the drainage layer, to act as a drainage layer, gradation 3 to 6 has been recommended by the MOTH. So coming to the history of the compaction mechanisms, in 1930 static mechanisms were used. Then with the implementation of dynamic compaction, standard Proctor, and for higher degree of compaction, modified Proctor was introduced. And after 1960s, the vibratory type of compaction mechanism was also used. And recently going to the literature, it has been found that the gyratory compactor has also been used in the bituminous as well as the roller compacted concrete areas to simulate the field compactions. So going through the trend, it has been seen that the impact type of compaction mechanism is still now in high demand for research. However, it has been observed that gyratory compactor is also, the research on gyratory compactor is also increasing to simulate the kneading and pressure of the roller compactors in the field. So for GSB, a very countable number of studies has been done to simulate the GSB with respect to gyratory compactor. And it has been seen that mostly impact type of mechanism is only used. And no studies has been done till now where there is a comparison of all the different types of compaction mechanism has been used to simulate the field compaction. Interlocking is also an important factor to study to understand the grain to grain load transfer, as well as morphology is also an important factor to study the interlocking. In the literature, it has been shown that only the surface texture is only studied. However, sphericity, form to D, gradient angularity, all those type of morphological studies are yet to be done. So there are some literature gaps, like comparative comparisons of different laboratory compactions has not been done. Limited studies are done with gyratory respector to simulate the GSB. Study of interlocking has been limited. And the breakage of aggregate matrix when applied to different types of compaction mechanism has not been studied. Since GSB is a drainage layer, it is important to quantify the breakage which might affect the permeability. So, and also the different type of morphological parameters are also important to study. These are the different types of compaction mechanisms which has been studied. Proctor, modified proctor with low and high compactive effort, vibratory hammer and vibratory table with low and high compactive effort, gyratory compactor, and as well as a baby roller has been used to in the field compaction to study the layers. The grade 6 of MORTH for the GSB was used for this study. It has been seen that with the impact type of compaction mechanism, the CU value increases, that is becomes greater than 6. So it becomes a well graded from gap graded gradation. So with respect to, irrespective of the type of the compaction, with the increase in compactive effort, it has been seen that the water content versus dry density graph shifted upwards. There is a strong correlation which has been found with respect to the OMC and MDD. So there are the different types of compaction mechanisms. Coming to the similar type of compaction mechanism also, it has been seen that there is a huge variation in the OMC and the MDD. There was no correlation found with respect to CBR as well as the permeability, but when it was plotted with respect to the energy, it has been seen that the CBR has a good correlation with the compaction energy that has been used in the lab. However, the permeability has still shows no correlation. Coming to the individual type of compaction mechanisms, it has been seen that with increase in the energy, the CBR increases, however, the permeability decreases. Okay, sir. There are several types of breakages that will happen. So it has been seen that with any type of compaction, the graph of the original gradation shift towards lab, that is breakage is happening. So these are the breakages that has been gradation of the breakages, and the breakage study has been done using different types of models which has been available, where they use the fractal dimensions to study find out the ultimate grade and quantify the breakage. So right now, where there was no relation with energy with respect to permeability, with breakage there is a good correlation. So coming to the morphology, it shows that with the sphericity of the aggregates increases with decreases with impact mechanism, and vibration increases the sphericity. For the flakiness elongation, the vibration mechanisms it decreases, and with kneading and pressure, it rearrangement happens. And coming to the form 2D, the impact type of mechanism increases the form 2D, and the vibration type of mechanism reduces it due to the cushioning effect. And coming to the gradient angularity, when there is a very high amount of energy has been applied to the matrix, more than 700, that time only the gradient angularity of the matrix changes, and which is generally applied by the impact type of mechanism. The texture also changes with respect to any type of compaction mechanisms. Then coming to the angle of repose, it also shows that there is no trend with respect to energy, but however, when the breakage was related to the
Please wind up.
yes, sir, last slide. But when it was related to the breakage, there shows a strong correlation. That is, with the decrease in the interlocking has been observed with the increase in the breakage. Though as per the graph, it has been it was supposed to be like the angle of repose should with the angle with the sphericity for the modified proctor, the angle of repose should be higher, but it was not seen in the results because of the formation of new particles. There are more number of fines that has been coming to the matrix, and the angle of repose got reduced. So these are the conclusions. Different type of lab compactions. There is a huge variation in the OMC and MDD, and right method to simulate the field compaction is necessary. Modified proctor compaction breaks the aggregate most, gyratory compaction breaks it least, and which affects the permeability. Compaction type changes the particle shape and texture, and impact compaction fragments the particle, and vibration mainly rearranges the particle. There is a clear relation between energy and CBR. Higher energy improves the strength, but it lowers the permeability. An impact method over-predicts the field compaction, while the vibratory hammer compaction matches the field results better. Understanding how particle lock together and transfer the load is a key assessing for GSB performance, and morphological changes help explaining the compaction effects. Thank you. For any type of questions, you may just contact me. Thank you.
Okay, thank you very much. So with this, we have concluded all the presentations. We'll take few questions, I think. Is it allowed? Maybe 2 or 3. Then
Sure.
co-chair will sum summarize and wind up. Is it okay? 10 more minutes it will take. आप पूछ लीजिए. चलिए, okay, now we proceed like this in another 5 to 7 minutes, that if you have any question, very specific, 2 or 3 questions we will allow, then I will give the mic to co-chair. He may ask few questions because he has noted down the details of the presentation. I also have some questions. I can recall it, but that I can do it at leisure time. So, and then he will wind up. So any questions from the audience? Very brief, to the point, specific. No statement. Yes. Mic दे दीजिए please. रवि शेखर, आप सामने आ जाओ या इधर आ जाओ. Dr. Ravi Shekhar from CRRI. Yes.
Thank you, sir. Thank you, sir. My question for the IIT Kharagpur Amarnath Reddy paper publication. So I have only one observation. I am not expert in the payment, but distortion modeling was done using the sine and cosine function for temperature relationship. So in the correlation, you have shown the linear kind of the model. So can you able to expand why sine and cosine functions are required?
It is yours. Who will answer it?
Yeah.
Sir, the linear...
Your answer has to be
Yes, sir, I'll be
very
specific.
specific.
Yes, sir. Yes, sir,
Be
I'll be
specific. Don't tell big story.
Sir, the graph that we have shown that linear is not the... Sir, it is a predicted versus measured thing. So it will be mostly linear only. So, but if we put the parameters and see the variation, that will be in a sine and cosine waves. So the model forms that we have chosen is based on the observation from the data, so that we have observed.
Okay, thank you.
I know something. Anyway, you can discuss later on also. You know him. One more. Yes. DJ. Mike. Please. Can you introduce yourself, please?
Hello. Yes, again my question is to Subhajit Banerjee, same topic. So you have done very nice research on, but I would like to use, how it can be used practically for highways to measure the distance, in different ways. Can you just elaborate very shortly?
Have you understood his question?
Can you repeat?
So you have tried to measure the theoretical radiative difference with the practically, and you have done almost 10-12 projects you have studied in India, the way I understand.
Sir, we did not study for 10-12 years. We studied only one time all the payment sections, but those payment sections were, few were laid 1 year back, few were laid 15 years back. So that is the thing, sir.
Okay.
Sir, sir, if we take the RUT depth of 10 years payment section, sir, we won't be in a position to predict give the calibration coefficients correctly such that you can predict. So we need a progression curve, then only the calibration parameters can be made so good such that it can predict the progression. Sir, as of now we have completed only one cycle data set. We'll be collecting 4 to 6 cycles so that for a given inputs, at any time we can predict we can get the payment RUT depth, sir.
Okay, basically you need to have a long-term time data.
Yes, sir. Yes, sir.
To improve the
Yes, sir.
further.
Yes, sir. Yes, sir.
Okay, thank you.
Still discuss later on. Now I request co-chairman to summarize in 2-3 minutes and then we will wind up. Okay, thank you very much. Thank you. So I leave it to co-chairman.
Sir, very nice presentation of all presenters. One innovative approach to melt snow in altitude region. As per by Pratik Jaiswal, as per his presentation, this result highlighted to dual role of the RGO, both improving the heat transfer performance and decreasing the snow melting time, which can help address snow accumulation on the pavement in mountain area of India. Then our second is development of low cost indigenous accelerate payment. But इसके में भी APTA में test can be utilized, test performance. And then influence of parent track, it is very important topic. इसमें अभिनव कुमार ठाकुर, the research focus on the technical challenge in the recycler concrete payment and how the parent track mineralogy influence the efficiency and the performance of the recycle aggregate. Then fourth calibration के बारे में था, preliminary rating के बारे में हो गया. Data driven is very important सर, रोड सेफ्टी के लिए पॉइंट ऑफ से बड़ा इंपॉर्टेंट था ये. इसके अंदर जो 5 and 6 मोस्ट ऑफ सिमिलर नेचर है सर दोनों. और इसके अंदर जो बेसिक चीजें हाई एक्यूरेट MLR मॉडल्स जो प्रेडिक्ट पेडेस्ट्रियन सेफ्टी मार्जिन एट अनसिग्नलाइज्ड क्रॉसिंग, हाईलाइटिंग द नीड फॉर इंफ्रास्ट्रक्चर अपग्रेड एंड अवेयरनेस टू बूस्ट सेफ्टी. बड़ा इंपॉर्टेंट. आज नितिन गडकरी साहब ने भी इसके बारे में काफ़ी अच्छा लेक्चर दिया था और हमें मोटिवेट किया था कि हम रोड अच्छी बना रहे हैं. रोड अच्छी बनाने के साथ आपको रोड सेफ्टी पैरामीटर पे भी बहुत ध्यान देने की आवश्यकता है. तो इस एंगल से ये बड़ा इंपॉर्टेंट, दोनों लेक्चर बहुत अच्छे थे, दोनों प्रेजेंटेशन दोनों ने काफ़ी अच्छा दिया. तो बट इसके बाद तो इंटीग्रेटेड डाटा ड्रिवन ये भी हो गया सर, डाटा ड्रिवन मॉडल इसमें गाइडेड सर. इसके बारे में इंटीग्रेटेड डाटा ड्रिवन अप्रोच पर मोबिलिटी एंड क्रैश रिस्क, इसके बारे में आपने काफ़ी, चेयरमैन साहब ने काफ़ी अच्छा ब्रीफ किया है इसको. इसमें असेस दिस सोर्स सस्टेनेबिलिटी ऑफ LDP ऑन द मैकेनिकल परफॉर्मेंस ऑफ एस्फॉल्ट मिक्स, आकाश सिंह ने दिया इसमें प्रेजेंटेशन. सर इसके बारे में भी आपने काफी ब्रीफ किया था कि फ्यूचर रिसर्च शुड फोकस ऑन ऑप्टिमाइज LDP डोसेज with cross linker and compatibility. And then last one is the comparative analysis of laboratory compaction technique. सर इसके अंदर जो बड़ा इंपॉर्टेंट पॉइंट है कि यदि हम GSB से लगाकर कोई सी भी लेयर की यदि फ्लेक्सिबल पेमेंट बनाते हैं तो सबसे इंपॉर्टेंट पैरामीटर होता है कि हमारी फील्ड में हम डेंसिटी कैसे MDD निकालते हैं. जो लेब बनाते हैं, लेब में हम MDD और OMC निकालते हैं, तो हमारा जो सोर्स हम फाइनल करते हैं उसके अकॉर्डिंगली ही हमें उसकी FDD और OMC निकालनी होती. यदि जब सोर्स यदि चेंज होगा तो बट नेचुरल हमारे रिजल्ट परफॉर्मेंस नहीं आएंगे. तो हमें सोर्स पे इस पे ध्यान देने की क्या आवश्यकता है. साथ ही मैं आपको और भी बताऊंगा कि जब भी हम MDD और ये जब करेंगे तो हमें ट्रायल लेंथ भी बनाने की बड़ी आवश्यकता है. ट्रायल लेंथ पे हमारे परफॉर्मेंस अच्छे आएंगे तो बट नेचुरल FDD और फील्ड में हम जो मेन रोड बनाएंगे, रोड प्रोजेक्ट पे जाएंगे तो हमारे रिजल्ट बहुत अच्छे आएंगे. इस बारे में भी काफ़ी अच्छा प्रेजेंटेशन था. नो डाउट जो हमारे सभी IITians स्टूडेंट थे ये हमारे कल की धरोहर है. ये आज इन्होंने प्रेजेंटेशन दिया है, बहुत अच्छा प्रेजेंटेशन है, लेकिन भविष्य में ये और भी अच्छा परफॉर्मेंस करेंगे और भारत की नींव और अच्छे से रखेंगे. धन्यवाद. थैंक यू सर. थैंक यू.
Very good presentations by all of you. There will be some, minor errors, major errors, and some deviations that you can always correct it. That is how you grow and learn. Okay? Thank you.
Thank you so much, Chairman of the station, Co-Chairman of the station, and all the respected presenter over there. Thank you so much. And now I request Chairman of the station, Dr. S. Gangapadar sir, for his concluding remarks. It's already done. And now I request once again Chairman of the station, Dr. S. Gangapadar sir, to present a memento to Sri Pratik Cheswal, Research Scholar, PMRF. Can we have the memento, please? Requesting everybody तालियों की आवाज आनी चाहिए. Well, next memento is for Shri Siddhanath Panda, IIT Kharagpur. Well, the next is for Shri Avinav Kumar Thakur, PhD Research Scholar, IIT Madras. Next, Shri Subhachit Banerjee, IIT Kharagpur. Thank you so much, Chairman of the session. Thank you. Now requesting our co-chairperson of the session to present a memento to Shri Nikhil Kumar Suman, Research Scholar and IT Patna. Next, Shri Amrit Raj, Research Scholar, NIT Patna. Shri Akash Singh, Research Scholar, IIT BHU. Next moment is for Shri Suranjit Saha, Research Scholar, IIT Madras. Thank you so much. And now, to felicitate our chairman of the session and co-chairman of the session, would like to take the honor to call Shri Arvind Tripathi, Chief Engineer, to please come on the dais and felicitate the chairman of the session and the co-chairman of the session. And requesting everybody, can we get some clap? Now requesting the chairman of the session, Dr. S. Gangapatar, sir. Thank you so much, sir, for your immense time. Thank you so much, sir. Now requesting Shri Arvind Tripathi, sir, to felicitate our co-chairperson, Shri B.P. Borasi, sir. Thank you so much, sir, for your presence and all your words. Thank you so much, Arvind Tripathi, sir. Thank you so much, the chairperson of the session, Dr. S. Gangapatar, sir, along with the co-chairperson, BP Borasi, sir. And thank you so much, all the presenter. We are just ending the session 1 here. We'll start the session 4 very shortly. Thank you so much, everyone. And now a kind request to all the ladies and gentlemen out there. There are so many empty seats आपके सामने है. So requesting everybody to please come little bit forward so that it will be easy to communicate. It will be easy to capture the good moments. Thank you. Check. Well, ladies and gentlemen, we are about to begin the technical session 4 for all the contractors, consultants, and NGOs. Oh, sure. Well, shortly we are going to start the technical session 4. I'm requesting all the presenter to please be present near the dais. Sure. Once again, a warm welcome to all the ladies and gentlemen out there on the 84th annual session of Indian Road Congress. And we are begin with the technical session for the contractor, consultants, and NGO. And first of all, let me welcome on the dais. The session will be chaired by Shri Sudeep Chaudhary, ADG North, requesting our respected Chair of the session, Shri Sudeep Chaudhary sir, to please join me on stage. I'm requesting everybody to please give a big round of applause and let's welcome Chair of the session on stage. Namaskar and welcome, sir. And the session will be co-chaired by Shri Rajiv Chittraj, Chief Engineer, retired PWD West Bengal. Would like to welcome sir on the dais. Namaskar and welcome, sir. Now I request Shri Narendra Kumar Ghadai, Superintendent Engineer, Work Department, Odisha. He's going to welcome our chairperson and co-chairperson with the flower bouquet. So let's welcome him on stage. Thank you so much, Shri Narendra Kumar Ghadai, sir. Now I invite all the presenters of the session to please come on the dais. Can we have on stage Shri G.L. Burma, Proprietor, Engineering and Planning Consultant, EPC. Let's give a big hand and let's welcome sir on the dais. Requesting Shri Vishwabikas Rao, Senior Manager, and Shri Sarad Prasad, Senior Engineer, L&T. Let's welcome them. Would like to welcome on the dais Dr. Dhanand K. Mishra, Managing Director, RAS Picked AI. Let's give a big hand and let's welcome sir on the dais. Requesting Shri Prakash Khandekar, President, and Shri Datta Kulkarni, member of Janak Roast, to please take your position on the dais. Namaskar and welcome all our respected presenters. Now I request Chair of the session, Shri Sudeep Chaudhary sir, to start the session with his opening mic remark. Thank you.
Hello. Yeah. Namaskar. So the session now is on is a technical session 4 for contractors, consultants, NGOs. So we have got some very topical and interesting presentation. Case study 1, lessons to be learned from flood disaster, village Dharali. Then characterization of a sustainable and semi-flexible composite pavement, drone inspection of bridges, and importance of road safety. So these are very topical, and the first one to be done by Mr. G.L. Verma. My co-chair here is Mr. Rajiv Chattaraj. He is retired Chief Engineer of West Bengal PWD. I welcome all the presenters here. So let us start the session without much ado. So Mr. Verma, Proprietor, Engineering and Planning Consultants. So yeah, 10 minutes is the presentation. So it is a project involving, in fact, my field of work in North India.
It is the case study of a Dharali disaster.
I understand, but I am actually looking after the Northern Zone National Highways, so I am directly basically concerned with this project. Anyway, you come over.
It's mine. GLB mine. Also, you don't need my laptop. Main folder. Sorry. Yeah, you just slide more. This is. No, but this is front. This is backward. So put it in the presentation mode. So good afternoon, chairperson, co-chairperson and fellow presenters and all the fellow engineers, fellow consultants, fellow contractors, not fellow contractors, fellow contractors and NGOs. So I am consultant to World Bank for one project you prepare in Uttarakhand. So in the last mission, I got a chance to do a case study for Dharali. You must have heard that there was so many loss of property, lives. There was a 30 feet of sediments which were brought by a tributary to Bhagirathi, which was Kheer Ganga. If you see that, this is after the disaster, you know. So this is Bhagirathi and this is a Kheer Ganga. Kheer Ganga is a glacier fed river. So this disaster, initially it was thought that it is because of a cloudburst, but then when more studies and initial data was gone through, then it was found that it was not only the cloudburst, there were combination of reasons. There were, you know, that it is, Kheer Ganga is a glacier fed river, and these are Gangotri glaciers. So these glaciers are crevices which have, you know, the crack, and they are just suspended. So as the temperature goes up, they are suddenly released, and then there is a sudden flow of snow, sediments. And other thing is that, you know, that the landform of this particular, which I will be showing to you, it is very, very interesting project, where you have a large amount of flat areas in the middle of the hill, where, you know, the saucers are there and their lake formation is there. So the lake keeps on rising up, it keep on storing the water. And when then suddenly there is a rainfall, then there is a sudden collapse of these lakes, and then it takes everything with it. So we went to the Google Earth and saw that the earliest image which was available was 2004. So if you see that, this 2004 image shows that there is already a alluvial fan cone-shaped landform created by earlier sediment during this collapse of these lakes, and they got deposited in most part of the Bhagirathi river. So this is the earliest image which is available. But you see that there is a suspension bridge also which has been constructed, and the end of this pedestrian bridge is on that sediment island, which was a temporary island. And you see that there is a very small, this is a Kheer Ganga. So after this collapse, the Kheer Ganga changed its course, otherwise it was flowing straight to Bhagirathi. So it changed its course and started flowing from here. So there were habitation, the village, Dharali village was on the bank of Kheer Ganga. If you see that there are very small bridges, and these are the small rivulets which were flowing through this particular area. So this is an image of 2011. You see that in the waterway or in the path of the earlier Khir Ganga, there are habitation which has taken place. So you see that these habitations and this, they are slowly being occupied. So there is an expansion of Dharali village on this temporary island, which was a sediment brought by Khir Ganga in the earlier floods. So this is the image of 2000. You see that heavy habitation which has taken place. And there is, that the Khir Ganga was forced to change its course. There were retaining wall which were constructed on both sides. So these are the retaining wall which has been constructed. So the Khir Ganga kept on moving. People keep on deviating the river, forcing the river to flow in an unnatural way. So this is a very good image, comparative image. You see that before the disaster and after the disaster. So everything was taken by this. There was a 15 feet of sediment which was further deposited in a 20 hectare of area. So there was a 20 hectare of area where 25 to 30 feet of, that filling was done by the slides. So if you see that this is Khir Ganga, when we try to play with the nature, it takes its own punishment, You see that Khir Ganga made its way, straight way into Bhagirathi. So this is, we are seeing from the other side. So everything was taken. These were the old houses which were constructed, they were not affected. So whatever subsequent habitation took place, the river took everything. There were many people who lost their lives, many properties were lost. And then when I discussed with the local people, they say that most of, that people who came here were from outside Uttarakhand. So when they come for tourism to that particular place, they don't enter into, that what is the area. They just open the tourism and the tourist and the hotels. The views are very good. One side is Bhagirathi, other side is Khir Ganga. So then they, suddenly when, the flood came, it took everything. So you see that Bhagirathi passage was also narrowed down. So this all was brought by Khir Ganga through its, sediments, through its slides from that Gangotri hills. This is the Char Dham road, which was totally filled with mud. So all these were, habitation came in the way of Khir Ganga, and river took everything with it. So now you see that this is the house which was 4-story. So everything is buried. So only this one is, you see, and this is the Bhagirathi. You see that the retaining wall was constructed. This is just before the disaster. So Khir Ganga, you see that how much amount of sediments and the flood it brought, and it was forced and narrowed down to such an extent. This was, the river was forced by this much width to flow only. So the experts have different views. So if I, that I show you the next image, it is very interesting. So this is the Gangotri glacier. You see this is the Dharali village, this yellow one. And this is the Khir Ganga. You see that these are the craters have the potential to hold the, that collapsing glacier. And then when there is a sudden cloud burst or when there is heavy rainfall, so suddenly it is, that lakes are broken and they just bring a very heavy discharge with sediments and then just take everything along the path. This is a glacier. This is a Gangotri glacier. And you see that, there are craters there on the way. It is such a steep it is 1:2.5 gradient is there, you know. It is 16, 17,000 feet is there, and in 5 kilometer, it comes down to 4,000 feet. So this is the another time, you know, the same glacier, you see that this is the Dharali village, and here you see that, you know, that the snow has melted, and then, you know, that slowly you see that brown hills. So cloud bursts are there, everybody knows that cloud bursts are there, but this is not a new phenomenon. It was happening all the times, but now disasters and you know, that loss of property and humans is becoming more because we are coming into the way of the rivers. So we keep on, you know, blaming the global warming and climate change, but in the process we are to blame ourselves also, you know, because we are trying to force the river to flow in another direction and we come into their way. So we'll have to pay the price for this.
Sorry to interrupt, Mr. Verma. 2 minutes. You have to conclude fast.
I'm just finished. So during that period only, this happened on 5th of August, and on 15th August, the same thing happened in Jammu and Kashmir. You must have known Chishoti in Kishtwar district and Kathua district also. Exactly similar things, glacier, same height, same landform, same topology, everything was same. You see that. This is in J&K, which happened on 15th of August, after 10 days of what happened in Dharali. Same loss of life, same village was totally buried. Exactly similar. You see that these are the glaciers, and this is the rivulet which was going to Chenab River, and this was the village. So this is how what happened, and you know that we come into the way of the river, and then suddenly we'll have to pay the price. So now we will have to see what is the way out that we should have, you know, the flood resilient design. We must ensure that river is not encroached upon. High level flood consideration, wherever such areas which are prone to such heavy floods, we should have the provisions for high flood level. Waterway should be 1.5 times. And we should try to give deep foundation if the bridges are there. We should see that there are no, you know, the habitation which takes place in the passage of the river. Regular inspections are required. Now we have drone, etc. We can see and go back. You know, there are very good data available with us. We are, you know, that images are available, satellite images are available, drones are there. You just go and see that what is landform and how it can affect the infrastructure. So additional precaution we must see, you know, that we should give early warning system is there, emergency response plans are there. And public education is very important, you know, that we should show that what river can do if you try to come into the way of their natural habitat. So this is what a small, I thought I must share with my fellow engineers that, you know, that this is what we should try to avoid. It is, everything is man-made, but we try to blame climate change and global warming and other things, but we must do our part also very sincerely. Thank you very much.
Thank you. So, next presentation is on characterization of sustainable semi-flexible composite pavement. Mr. Sarath Prasad. You have 10 minutes, Mr. Prasad. 10 minutes.
Yes, sir. So good evening all. I am Sharath, representing L&T Constructions. here to present on the topic characterization of sustainable semi-flexible composite pavements. So before going on to the topic, let me just show you what is like, where am I from, what am I doing. So I am basically from the Research and Testing Center as part of the L&D Constructions, that is LTCRTC. So we are an NABL accredited lab as well as we are DSIR recognized lab. So we are having around 33 to 231 parameters are there for our NABL accreditation, and we are supporting all of the L&D project sites across the country. So these are some of our testing facilities that are available within our laboratory premises. So we have a scanning electron microscopy, strand testing equipments, other geotechnical pavement testing equipments like fatigue, rutting, even resilient modulus testings. Similarly, we have other testings related to concrete as well as even for our structural testings as well. So as L&T, we have been part of the India's first composite pavement construction, which was helpful enough to reduce the thickness even by 40%, and if, that helps basically in reduction of 30% of the natural resources. So these are some of the projects which we have been doing in the previous years. So like incorporation of waste plastics, usage of potholes. So we have also been fortunate enough to be part of the addition of our HSR project, High Speed Rail, where we have done projects regarding the cement asphalt mortar, mostly known as CAM. Also some projects related to warm asphalt as well. Nowadays, 3D printing, textile reinforcements, these are some of the projects which we have been doing across the country. So coming on to the topic, this is the outline of my presentation today. So we know already there are basically two types of payments which we usually see, that is the flexible payments as well as the rigid payments. And also there are a separate type of payments known as composite payments, which incorporates the utilities of both the flexible payments as well as the rigid payments. So, but coming on to the whatever the payment it is, we used to see mostly that different types of failures that happens in our payments, such as permanent deformation, fatigue cracking, moisture damage, as well as thermal cracking. Also, this usually happens mostly in our flexible payments. So, as a generic, we got to find out that the composite payments used to give a better properties compared to these flexible as well as rigid payments, which has both the properties of together. So, as a composite payment, CGBM, that is the cement grouted bituminous mix, that has both the properties of our rigid payments as well as the flexible payments. So, if you come to see how the CGBM is constructed, so it is basically a open graded friction course that is consisting of a flexible layer, then in which we are incorporating the grout into the mixture. So this will basically help us in solving both the rutting as well as the fatigue properties. So these are also heavy duty payments that doesn't need any joints like our rigid payments. So these are some of the pictures that relates to CGBM. You can see in the video down there that how the penetration of the grout is happening within a CGBM layer. Also, there is one of the disadvantages that the fatigue layer or the fatigue happening in the CGBM, because of the rigid layer, rigid properties, it is lesser. So we came to a thought process that how we can improve this property. So this led to our thought process leading to why we can't use an emulsion instead of a binder or a VG30 binder. We will use a VG30 based emulsion. This will give us a better performing fatigue properties. So this thought process led to our concept of BCGBM as well as ECGBM, where our OGFC will be constructed using a bituminous layer or a emulsion layer. So this will basically lead to two parts. One is BCGBM, then other is ECGBM, into which we will be pouring the grout which is designed. So these are various samples. So for this, we need to initially develop an OGFC, open graded friction course, which has around airwords of 30 to 35%. This is the gradation which we have used across. And for both ECGBM as well as BCGBM, we need to finalize what is the number of Marshall blows that we need to cast for a required thickness of sample. So these were finalized as 40 and 47 as well as 50 for correspondingly BCGBM or the ECGBM. And the cementitious grout were also designed as per IRC SP 125. So the major mechanical testings that corresponds to any of the materials is, one is Marshall testing that everybody will be doing for our bituminous mixtures. So we have done, usually we will be seeing 21 kilonewton similar values, but coming onto a CGBM material, the master stability should be 60 kilonewtons. So if you see across different, so if you see across different aging criteria, since there is a grout coming into the picture, you need to see what is the strength gain that is happening over 3 days, 7 days, and 28 days. So you could see that there is an improvement of the master stabilities that is happening across different, both ECGBM as well as BCGBM. Similarly, there has been increase in the flexure strength as well over the time period passage. The compressive strength also, you could see that there was a minimum requirement of around 5 MPa, and we could see that both for ECGBM as well as BCGBM, after 28 days it went to 5.5 MPa as well as 7.5 MPa, which is high above that. But with the incorporation of emulsion, we could see that there is a slight reduction that is happening with the ECGBM that have been designed for. Similarly, indirect tensile strength as well also was meeting the required strength, and as well as the resilient modulus test was coming around 15,000 as well as 14,000, which is a major governing factor for our designs, which will in turn actually reduce the thickness of the payments. So that is going to basically improve the usage, basically it is going to reduce the percentage of usage of natural resources. Coming on to the major part, that is the performance that we look through finally onto the pavement. That is basically the rutting as well as the fatigue that we are going to see here. So basically the design what we did for, why the concept of ECGBM was thought, because we needed a higher, better performing fatigue resistant composite pavement. So this has led to our thought process, and we could see that with the inclusion of this emulsion into this picture, we were able to get a CGBM that was performing 1.5 to 2 times better fatigue resistance compared to a BCGBM. Also similar to our any CGBM material will give you a better rutting performances compared to any of the HMI layers as well. So here also similar way we were able to get a good rutting performances for our CGBM layers, both ECGBM as well as BCGBM. ECGBM slightly had a higher rutting because you know there is a incorporation of a unaged binder that is coming into the picture. So we did some image analysis for both ECGBM as well as BCGBM to understand why this kind of reduction in strength is happening, to just basically to confirm what is the reason behind that. So we did this using the software ImageJ, and we could find out that the amount of blackened area, that means basically the bitumen area, is much more in our BCGBM compared to ECGBM, where this has led to higher strength values, higher property values that we were seeing across the different slides before. Also, we have done some energy comparisons. Here, we could see that the incorporation of CGBM itself is leading to a higher energy consumption compared to any of the HMI layers. This is mainly because of the incorporation of the grout that contains cement grout, which is going to come into the picture, which is constituting around 56 to 72% of the structure. So this is basically going to increase the energy consumption that is required. So, but when we compare across BCGBM as well as ECGBM, one more added benefit that we get here is that we don't want to heat the bitumen. Here you are using an emulsion where you don't want to heat it, it is going to break over the time period. So this reduces the usage of fuel for burning the bitumen. So as a conclusion, both the BCGBM as well as ECGBM has helped us to met all the requirements which was as per IRC SP 125. Mechanical properties of ECGBM was comparable with BCGBM that usually we see across, and the rutting performance were also comparable, but the main factor, that is the fatigue performance, has improved 1.5 to 2 times compared to our BCGBM. So also compared to BCGBM, this is much more of an eco-friendly solution. You can see some of the constructions that we have done for some 100 to 200 meters trial structures that we have constructed. And thank you. That's it.
Thanks, Mr. Prasad, for speaking on to the timeline. Dr. Dhanada Misra, please. Drone inspection of bridges and how it helps repair and maintenance.
पेन ड्राइव टा जो कर दिली कॉपी कर दे इसलिए क्या है देखा आर्किटेक्ट नो से पेन ड्राइव टा कॉपी Sorry about that. Good afternoon. I think there is a error in the copying of the file. While we are waiting for that, let me introduce myself. My name is Dhanada Mishra. Actually, I am based out of Hong Kong, and just open the. Yeah. Oh, it copy कर देते हैं. Can you copy it to the file and then. So I'm here to talk to you about the use. Just give me a minute. Yeah. Adam. All right. Okay. Good afternoon. Thank you for this opportunity to present to you the work that we have been doing at Raspect, which we are trying to bring to India through our partnership with IRC Techno. My name is Dhanada Mishra. I'm based out of Hong Kong, working with Raspect for the last 4 years, developing autonomous AI-based robotic inspection technology, which is applicable to most built infrastructure. Today, I'll mainly talk to you about bridges and bridge inspection. You can see in this slide a range of applications of this kind of technologies, mainly for smart city infrastructure, whether they're tall buildings or tunnels or bridges or power supply systems and so on. Mainly, we'll be talking in this presentation about how we can deploy drone-based inspection technology to reduce safety risks of inspection, take out inefficiencies, and have better data management, which will help you in life cycle maintenance of these valuable assets. So typical pain points of contractors, of bridge inspectors, of engineers and surveyors, and government agencies are very well known. I'll not go into details of this. When you are using traditional approach, there are a number of difficulties that we encounter. We can address many of these through robotic autonomous inspection, particularly of bridge infrastructure. Now, bridges, of course, have been in news for the wrong reasons, for various defects and safety issues leading to collapse and so on. But using drones particularly, autonomous, robotically we can inspect and assess the bridge condition and take up preventive maintenance or predictive maintenance. So you can see here a few types of data that you can collect, very general inspection data to very close-up inspection data, and that can then be used by AI to identify defects like cracks and spalling and so on. And so I'll just quickly skip through some of these slides. And basically, it would involve 4 steps. The first step is, of course, data collection. Second step is uploading the data to our cloud platform, which is called Inspectica. Then running the AI analytics to identify the defects. Now, we have millions of images that are used for training of the models, and then generating a report to create an inspection report. And you can also create a 3D model of the bridge you are inspecting. So there is a digital twin or digital replica that anybody can inspect by sitting, going to the platform on the cloud, and really the engineer can see what the drone pilot has collected, and then accordingly identify the defects, characterize them, make calculations, and prescribe the repair maintenance work that needs to be done. Now, these are the different steps. So data acquisition, data upload, and localization, which is a very important step. AI analytics that identifies the defects, and then the classification both in terms of defect classes and defect severity, critical defects, major defects, moderate defects, minor defects, which will then affect how you handle the repair maintenance process afterwards. So these are some of the key deliverables when you adopt this kind of technology, and it'll get a full set of data, but more importantly, you'll get a life cycle sort of maintenance platform where the inspection data is actually the starting point to then create the strategy for better maintenance and maintaining the safety of your asset. Where drones cannot be used or cannot access the surface of the structure, we have a defect capture app. Whenever you are doing your site visits, you can use this app to collect important information through visual data that can be then combined with the drone data. And this is a very, very important, very useful tool. The last thing that we also recommend to use is another cutting-edge technology called microwave scanning. And this can actually tell you what is happening inside the structure. Now, this can replace a number of non-destructive testing that we traditionally carry out after visual inspection. So in this case, you can actually see the condition of the rebars, you can see the voids, you can see delamination defects. So all of the issues inside the structure that causes the cracks and spalling on the surface can be detected using microwave scanning. So these are some of the steps that are involved. Now, I'm very happy to note here that there's a guideline for inspection of bridges using drones that IRC is already considering. There is a committee that has come out with a very detailed guideline, which I have gone through, and it's very good. And I hope it is very soon adopted and implemented in the field. And so just to give you a quick idea what steps are involved, so you have to have a very detailed flight plan that the drone can follow, so you can get 100% of the data. And these are some of the case studies from projects that we have done in Hong Kong. We did about 20 bridges last year, and a typical bridge for here example, you can see about 3,600 images were collected, 3,500 or 3,350 the number of defects that were identified, and they were categorized to defect classes and severity levels. Now, I don't know if I have the time, but there is a 2-minute video here that shows you the platform and how it works. So basically, once you have an account, you can actually use it on a SaaS model where you can upload the data, and the platform actually helps you to analyze and identify the defects and then generate the inspection report automatically. It's a very quick and very efficient way of handling inspection. And once inspection is efficient and and low cost, then you can do it more frequently. And therefore, like my earlier speaker was talking about the bridges in that particular cloudburst event, that we can take better care and we can understand the problems before they become a safety issue and cause a collapse, which unfortunately is happening quite frequently these days. So that's why I feel that this kind of technology with the drone sector being very aggressively developing in India, and a lot of startups are coming up, with this kind of technology we can really take better care of our built infrastructure. So I will really go through this video quickly and show you how it looks like, and I'll be very happy to talk to you. We have a stall in the exhibition along with our partner Architecno, and please come by and I'll be happy to talk to you in more detail. Thank you very much. Thank you, sir, for the opportunity.
You can play the video.
Sorry. Given that we are running out of time, I thought, in 10 minutes, this is the most we could do. But here again, just to go through the video, you can capture all of the information about the structure, and you can capture all of the inspection information, whether it's the visual information in form of images, in form of thermal images, which can also show you some of the defects below the surface, in terms of the LiDAR data, which can help you to create a digital twin of the structure, which can also be converted into a BIM model, or if you want to carry out a structural analysis, the same data can be used to create a 3D finite element model, for example, where you can carry out further detailed analysis. So in this case, you can see a particular case from Hong Kong, and this is where the media is uploaded. So we have an inspection, a media folder where once you have the access, you can upload the data, and then it will automatically position the data and use the images to create a photogrammetry model for you, and then position the defects that are identified in the right locations, so you can see the bubbles on the structure. In this case, we have used an image to localize the data, but you can also use the structural drawing if it is available to tag the defects on the images. And so it becomes very, then you can click into the tags and then see the structure and see it in detail. You can zoom in and zoom out and understand the defects and review the data. Sometimes AI will make mistakes, so you can make corrections to it. You can put in your comments in terms of how severe the defect is, or whether you don't agree with the severity predicted by AI, and then you can input your comments about how it should be repaired. So all of this can be captured automatically into a very detailed inspection report that can be formulated, customized as per the requirements of the local authorities or local standards and so on. So that's about it. I would be quite happy to take questions if you have any. Thank you so much again.
Okay. Thank you, Dr. Mishra.
Thank you.
The next set of presentation is from Shri Prakash Khandekar, President, and Shri Datta Kulkarni ji, Member, Jan Akrosh.
IRC हमारा लगा दो ना
PDF दिया आपने?
हाँ यही है
आ भी नहीं रहा सर।
इससे करना इससे नहीं आएगा
नहीं हो जाएगा वैसे, आप इसको ऐसे ऐसे करना पड़ेगा, 2 उंगली से करना पड़ेगा आपको ऐसे।
ठीक है चलो ये नहीं आता ना इससे नीचे नहीं वो नीचे नहीं आ रहा था नीचे फर्स्ट स्लाइड जाना पेन ड्राइव जो क्या
आप नहीं पेन ड्राइव में भी यही होगा ना आपको। आप पेन दे दीजिए अपना पीपीटी उसमें कैसे है ये पीडीएफ है। हाँ पीपीटी दीजिए
सामने का निकाल दो सर हाँ ये एडॉप्टर निकाल दो
ये वाला
IRC
इसके राइट
ठीक है हाँ आला ना नमस्ते मंच पर उपस्थित सम्माननीय जजेस तथा प्रेजेंटर्स और उपस्थित सज्जनों, मैं जनाक्रोश एनजीओ की तरफ से आपका स्वागत करता हूं। जनाक्रोश एक एनजीओ है, गत 12 सालों से ट्रैफिक अवेयरनेस के लिए काम कर रही है। हम रोड सेफ्टी के लिए काम करते हैं। रोड सेफ्टी यानी क्या है? रोड सेफ्टी, जो लोग रोड पे चलते हैं, गाड़ियाँ चलती है, उसके बारे में हम आपको बताते हैं। हम स्कूल, कॉलेजेस, ट्यूशन क्लासेस, उसके बाद ऑफिसेस, बैंक्स, जहाँ भी हमें मौका मिले वहाँ जाकर हम प्रेजेंटेशन करते हैं। हमारा उद्देश्य है कि सबसे ज़्यादा से ज़्यादा लोगों तक पहुंचकर उनकी जान बचाने का प्रयास करते हैं। इस तरह हर जगह जाते हैं। रोड पर हर बुधवार को नागपुर में एक चौराहे पर रहते हैं, लोगों को रिक्वेस्ट करते हैं, पुलिस का काम नहीं करते। उसी प्रकार पुलिस ट्रेनिंग स्कूल, एनसीसी कैंप्स, हम जहाँ जहाँ हमें मौका मिलता है हम जाकर हम प्रेजेंटेशन देते हैं, ताकि ज़्यादा से ज़्यादा लोग पहुँचकर हम ट्रैफिक अवेयरनेस के बारे में लोगों को अवेयर करने का कोशिश करेंगे। इस तरह हम हर जगह जाते हैं और पुलिस अवेयरनेस का काम करते हैं। इसके बाद आपसे खांडेकर सर बात करेंगे।
Namaste. I will continue with the presentation. This is a very serious topic. We have been working over this for last 12 years because road safety is related with all the users of the road. It includes everyone, even the pedestrian also is there. So this is what we have been doing. We have been there for last 12 years, I told you, because although we have only 1% of the vehicle of the world population, the accident number is 13%, which is not good for the country. In accidents, we are number one. That is not a good thing, good sign. So everybody must have concern for that. And so we are doing that and we are on that. Because national loss also is consequential there. Almost 3% national loss is there. We can have a comparative figures since last 2008 up to this 2023. Almost 8 to 9% growth is there. No reduction at all. Although government as well as NGOs are working over it, everything is possible. The last year, 9% was increased, it is 1,72,000. This is death on road. This is death on road. However, if we look to it from other angle, for every 3 minutes, one person is died on road. 474 or 475 persons, daily those who are out their house for job, working, business, whatever it may be, 475 persons, body is brought to the house in the evening. I mean, such a loss is there. Permanent loss to the family, to the society, as well as to the country also. So, important part of that loss is 18 years to 45 years. The productive group of this country is lost in these accidents on road only. So, that is more important. We have to take care of those people, those who are productive, those who are really at the helm of affairs. So, after looking towards number of accidents as well as the injury of the persons, 4.5 lakh are yearly figure for the injured person. Can't say how long that injury will continue. May continue for a week, may continue for 6 weeks, may continue for 2 months, 3 months, or even finally that person may go on wheelchair. But the overall GDP, if we look into it, is 2.5% reduction in the GDP. If we go into transfer into monetary terms, we are losing 220 Rafale's cost. 220 राफेल हम खरीद सकते हैं, इतना हमारा सालाना लॉस होता है एक्सीडेंट के कारण. So we have to be serious about it. Everyone has to serious. There are certain reasons. Speed, then wrong side, दारू पी के गाड़ी चलाना, then use of mobile, then red light jumping, and so many people have a shortcut which cut short their life. So we have to be there. Again, use of mobile, everyone know. Since 2005, everybody has lost the patience. उनको लगता है कि मोबाइल में जैसे 2 सेकंड 3 सेकंड में मैं अमेरिका बात करता हूँ तो यहाँ भी वैसी सभी बातें हो जाएगी. सो वी हैव टू सीरियस एंड एजुकेट द पीपल. दैट इज़ व्हाई वी आर देयर. दारू पी के गाड़ी चलाना हानिकारक है, ये मैंने आप लोगों को बताने की ज़रूरत नहीं है. नाउ देयर आर सो मेनी सेफ्टी मेजर्स इन कार. सिंपल थिंग इज देयर. बेल्ट. We have seen that number of people are not using those things. Helmet, because that is the only safety guard for our head. Medical science has improved, so many things are there, like Jaipur foot and all those things we can have. But head cannot be repaired. We can't have another head. So we have to be very cautious for that. But we are not that much cautious. That is really a shameful for our people. So again the shortcut, like this, people opt for this. Even they wanted to save their time, they wanted to save their fuel, but that doesn't mean that is fruitful. That is not usual. That again encroaches on others' area. We fail to understand that. Serious injury is there. Long disability also is there. Then family is devastated. Then you have to face legal proceeding also. Natural cause I have told you. And damage to the vehicle. 12.5 lakh vehicles are annually damaged. Those are out of use. So there are reasons also to save those things. Main reasons are they wanted to save, I told you just now, the fuel. Then they are overconfident. They disregard the traffic rules. False notion is there, मुझे क्या होता है भैया? Then they have acquaintances with powerful people, those who are in power, and laxity of enforcement. The enforcement agencies are not that much strong. Maybe there are certain reasons for them, but that is lacking there. So our suggestion to the government also, that we should have a good standard first class driving schools. Then strict licensing system has to be there. घर में बैठ के आज लाइसेंस मिल रहा है हमारे हिंदुस्तान में, आपने भी सुना होगा. Then education has to be there for, क्योंकि एक बार जिंदगी मिलेगी, हमेशा जिंदगी नहीं मिलेगी. क्लियर साइनेज, बोर्ड होना अच्छे, दूर से दिखना चाहिए, बोल्ड में दिखना चाहिए, so that people will be alert, drivers will be alert. Then increase in penalties has to be there. हमारी तो ऐसी आदत हो गई, हमारे को क्यों इतनी पेनल्टी होना, हम तो टैक्स देते हैं. अरे भाई हम गलती कितनी करते हैं, और जब गलती होती है तब कोई बचता नहीं है. एंड एनफोर्समेंट हैज़ टू बी स्पीडी with special guns, speed guns are there, cameras are there, and those enforcement has to be there. So those will definitely save further. Those are policy suggestions for government also. Use technology so that recovery of fine can be have. Then suspension of license has to be there. Fast track courts to be there so that final disposal will be very fast. Then reduction of insurance cover has to be there where shortcuts are used and accidents are taking place. Then community services to be, traffic violator has to be there, so that we can have overall control over those defaulters, so that we can reduce, because there are saying 80% of the accidents are human error accidents. So we can learn something from the mistakes and reduce the incident of accidents. That will save our national property also, and precious human life we can save. So that is what we wanted to suggest. This work is not done or will be sufficient by doing by NGOs and government. There has to be everyone to be serious about this. All should come together and indirectly help us to reduce this incidence of accidents and death, so that we will achieve something. So please join us and help us. Thank you very much.
With that, we conclude the presentation session for the technical session 4, and we may have few questions. Floor is now open for questions, if any.
Hello, I am R.S. Mahalaha. I have a question. Hello, yeah, I am R.S. Mahalaha. I have a question to IRC Techno. That is regarding the bridge inspection unit. Now several cable-stayed bridges and extruded bridges are under construction in India. Do you have any arrangement for inspecting the cables?
Thank you for the question. I think the same principle that I mentioned, using robotic inspection, sensors, collecting data, processing with AI to identify defects, can be applied to any number of structures. So whether it's bridge, whether it's cable-stayed bridges, I think you are mentioning
Yes,
about cables, right?
my question is particularly for inspection of cables.
Cables, right.
Yes, cables.
Definitely
Yeah.
it can be used for that as well.
In USA and other countries,
Yes.
they have developed some robotic inspection units. The robot goes along the cable and inspects.
Oh,
it.
yes, yes.
So have
That's a
we-
different type of robot you can use.
Do we have that product?
Yes, we can, because we are a software company, we manage the data analytics part.
Uh-huh.
So we use different kinds of hardware-based sensors. Drones are just one type of sensor.
Drone is one, but drone is not useful
but
for...
Yeah, for cables, you have cable climbing robots that can collect the data.
Uh-huh.
But eventually they will collect some form of an image or some signal that has to be processed to find the defects.
Yeah.
So that part can be handled by our software.
Can-
And if you have a requirement, we can find a hardware partner to supply the robot as well.
Okay.
Yeah, thank you.
Any more questions?
Good evening, sir. Myself, I am the DIGPA executive from the PWD Telangana. So it's regarding the question for robotic-based inspection. The presentation was interesting, sir. But can it traditionally replace the traditional NDT methods which we use like ultrasonic testing and the radiographic testing? And what is the validation? Have you done anything with the NDT data which was collected from your real life practical studies? So and how far the robotic testing cannot replace the traditional methods?
Yeah, so what I understand from your question, you are asking whether what I presented can replace traditional non-destructive testing methods, right? So normally in inspection, you have the first step is a visual inspection, right? A condition assessment. So that first step is best done using drones and collecting data like visual images, thermal images, LiDAR data. And from that, the defects that we identify can be further investigated using non-destructive testing, right? So generally, we decide where to carry out NDT based on a field visit where we sample check the structure. whereas the drone can give you a 100% check on the entire structure, leaving out nothing, and the AI can, without the effect of human error or human influence, can identify the issues which are important. Once you have done that, then you have a better, data-driven decision making in terms of what NDT method is best suited for the problem that you are facing, right? So one of the NDT that I presented was microwave scanning. Now, microwave scanning is the latest NDT technology which can give you a direct visualization of what is going on inside the structure that is causing the defects on the surface. And it can replace a number of other traditional NDT, for example, impact hammer test, ultrasonic pulse velocity test, or corrosion mapping, resistivity tests, or many of the other tests. They are mostly indirect tests. They correlate certain parameters based on the test results. But microwave scanning, for example, is a very good alternative to many of those tests. But still, depending on the situation, some traditional NDT tests may still be required before you can prescribe a proper repair and maintenance, solution to the problem that is being faced.
Some of the defects are hidden. They're not visible from the outside, on the surface. So that is my question is towards that.
That is what I'm saying, from the surface you can see cracks, you can see spalled concrete, you can see corrosion, you can see leakage problems, you can see many things from a photograph, right? Or from a thermal image, like an infrared image. But there are many things that is inside the surface that you cannot see, like voids, delamination, debonding, corrosion condition of the rebar. So for all of those things, you can use microwave, which is the latest technology. But there are other traditional NDT methods also can be deployed, right? Yeah.
I have a question. What is the range of accuracy of the AI analyzed data?
So I think in terms of AI accuracy, it can reach up to 95, 99% for certain classes of defects, for certain types of buildings, but I'll not claim it to be 100% in every case. And that's a good thing because that forces us to check everything that the AI predicts. So we have human experts who would check before we release the report. And then we have a professional drone, right. And then eventually a professional has to endorse the report. And before the professional endorses, we must have a human check. So that is how we ensure that no defects, are false positives, let's say. Yeah.
Do you have any simulation models or any validation models based on which basically you do this analysis?
The accuracy.
Yeah, accuracy part.
Yeah, so we validate the results by manually checking sample data. For example, in Singapore, they have a periodic facade inspection law, which requires every building to be checked 100% by drone, and then 10% of the results must be manually checked through either rope access or through building BMUs or something, gondola. So those data shows that the drone predicted defects are close to 100. Absolutely, and they're validated through that. So we have lots of data like that, about 100 plus buildings we have done in Singapore, which gives us a lot of confidence. Thank you.
More questions? Yeah.
Hello. Sir, can you tell us the life of the bridge using that data?
Yeah, so predicting the remaining life of the bridge is your question, right? Yeah, so that the data that we collect will definitely help in doing that. But there are other models into which you have to feed your data in to simulate the deterioration processes and how the defects evolve through multiple inspection cycles to come up with a remaining life prediction. But the main thing there is that beyond the visual information, thermal information, you need the corrosion condition of the rebars, and that can be obtained through the microwave scanning, and that can go into the model that can predict the remaining life. We can certainly do that, but at the moment, that's not a major area of our focus.
Anything else? more questions. If there are no more questions, then I think we should be concluding. Co-chair would like to sum up.
Good evening, my chair, Mr. Shudip Chaudhary, the presenters, esteemed presenters, and the, all the participants of this IRC annual session. There are four very interesting presentations on various topics. The first one is by Mr. G.L. Verma on this flood disaster on the Dharali village. The presentation has shown it's basically an eye-opener. In the hilly region, we have, in our country, we have got a lot of hilly region, and there nowadays, recently, lot of this sort of disasters are happening. So the case studies are very, very important. He has shown the photographs before and after, and also he has suggested some way outs. But here we have to, in this forum, we have to also think whether we need to change the IRC guidelines for the bridge design for this region structures or not. Next one is for the characterization of the sustainable semi-flexible composite pavement by Mr. Sarath Prasad, am I right? Okay, of L&T. He discussed about already existing technology CGMB as per IRC SP 125. He has suggested some alternative materials and some improvements of this technology. And I would request him also to report these results, performance-based results, here in this country also. This is a dearth of such data, and for the performance of such data and reporting to the IRC for the improvement of the existing codes. The third one, we have on the drone-based inspection of the bridges. Recently, we have seen a lot of application of the drone technology. Those are on the wars we have seen. Here are some constructive side of the application of the drone technology. He has shown very interesting things on the life cycle assessment of the important infrastructures like bridges and AI application analysis. We have discussed some questions we have faced. So, and also the one good thing, microwave scanning of the structures, which can replace actually many NDT tests. If I have asked also, what is the range of the accuracy? He has answered that as 95% around, but that is pretty good. This is a good technology. We look forward for the application of such technologies. And the last one is on the road safety by Mr. Khandekar and Kulkarni. They are basically doing the, as an NGO, they are doing the social service towards building the awareness of the road safety. They have shown by the data how this road accidents in India is affecting the loss in terms of the GDP and every other data. But after doing all these efforts, however, the road accidents in our country is not appreciably reducing. That is a matter of concern. He has suggested, they have suggested some good suggestions. I think out of that, the process of the issuance of the driving license is very important. That's all. Thank you.
With that, we conclude the session. Yeah, thank you.
Thank you so much, the chairman of the session and the co-chairman of the session, all the presenter. Thank you so much. And now I request the chairman of the session to present the memento to all our presenters. So would like to request Shri Sudeep Chaudhary sir is going to give the memento to Shri G.L. Burma, proprietor, Engineering and Planning Consultants, EPC. Can we have the memento, please? Requesting our chairman of the session to give the next memento to Shri Vishwavikas Raut, Senior Manager, and Shri Sarab Prasad, Senior Engineer, L&T. Now requesting Sri Rajiv Chitraj, our co-chair of the session, to give the moment to Dr. Dhananki Mishra, Managing Director, Raspict AI. Let's give a big hand, everyone. Also requesting our co-chairperson to give the moment to Sri Prakash Khandekar, President, and Sri Datta Kulkarni, member of Janak Rosh. Now requesting Sri Jyoti Ranjan Satpathy, Chief Engineer, Works Department, Odisha, to please come on the dais and present the moment to our chairman of the session and the co-chairman of the session. First, we are going to felicitate our chairman of the session, Sri Sudeep Chaudhary, sir. Thank you so much, sir, for all the knowledge all the time. Next, I would like to request Sri Jyoti Ranjan Satpathy, sir, to felicitate our co-chairperson, Sri Rajiv Chitra, sir. Thank you so much, Jyoti Ranjan Satpathy, sir. Thank you so much. Thank you so much, everyone, our respected chairperson, co-chairperson, and all the presenter. Thank you so much. An important announcement. We'll begin the technical session 5 within 15 minutes. So kindly be seated, kindly be here in this hall. And requesting everybody, please come a little bit forward. It will be easy to communicate with everyone. Thank you. Check. Well, a very good evening, all the ladies and gentlemen who are about to begin the technical session 5. So requesting everybody to please kindly settle down. Check. Once again, a very good evening to all the ladies and gentlemen out there. And I think we are all set for the session 5, technical session 5. So without delaying, we directly call and introduce you the chairman of the session, Shri D. Roy Chaudhary, Chief Engineer, CPWD Mumbai. Let's give a big hand and let's welcome sir on the dais. Namaskar and welcome, sir. And the session will be co-chaired by Shri P.R. Chandak, former Director Projects, Rajasthan PWD. Let's give a big hand and let's welcome sir on the stage. Good evening, sir. Welcome. And now I would like to request Shri Narendra Kumar Ghadai ji, Superintendent Engineer, Work Department, Odisha. He's going to welcome our chairperson and co-chairperson with the bouquet. Thank you so much, sir. Now, I'd like to invite all the presenter of the session to please come on the stage. Would like to welcome Tata Steel Limited, the presenter of Tata Steel Limited, the presenter of Revloc Concrete Barriers Safety First. Would like to welcome on stage Honeywell International. Can we have on stage Tikitar and Cell India Private Limited? Would like to welcome our representative of Makaferi Environmental Solution Private Limited, Power Arch Innovation Private Limited, Nagpur. Can we have on stage Jal Nidhi Bitumen Specialist Private Limited? Can we have on stage Secura India Management Limited? Would like to welcome on stage Utkarsh India Private Limited. Can we have Bentley System India Private Limited? Would like to welcome our representative Vishwa Shamrudh Engineering Private Limited. Can we have Uritech India Private Limited? Well, last but not the least, Jindal Stainless Limited, New Delhi. A warm namaskar and welcome to all our respected representatives. Now I request Shri D. Roy Chaudhary sir, the chairperson of the session, to start the session with his open mic ribbon. Thank you. Check, check.
Hello. Yes. It is my pleasure to welcome all the delegates. I would request those who are standing behind to please come up front and be seated. I welcome the co-chair as well as all the presenters from the industry in this session. There are, I think, 13 presenters, and mostly we will have to keep to the time, which is 8 minutes are given for each presentation. So without wasting any further time, because we are already delayed, may I request Shri Prashant Kumar of Tata Steel, latest construction solution by Tata Steel, by Shri Prashant Kumar.
Hello, am I audible? Yeah. Very good evening to all of you. I'm Prashant Kumar, Head of Construction Solutions in Tata Steel, and I will be presenting the presentation on the latest construction solutions we have and Tata Steel offers. I will be joined by my colleague Mike. Mike, I'll request you to please come here. Yeah. So we offer construction solutions. So there is a reason why we are saying that we are offering construction solutions, because there are problems in the industry. There are problems in the terms of wastage, short delivery timelines, high cost run, reconciliation and manpower unavailability and all, right? So Tata Steel is into the construction solutions, and we provide cut and bend solution under the brand name of ReadyBuild, and that can offer you sometimes a saving of around 8,000 rupees per metric ton. This is the kind of complexity we handle. This is the kind of complexity we handle for your requirements. And we are also into Bhopal cages. And these are the machines which we use. These are the sophisticated machines which we use for providing you all the latest construction solutions, the reinforcement solutions we have. Tata Steel is also into the rebar couplers. We have our own rebar couplers. We manufacture our rebar couplers, and we serve these couplers through the state-of-art, these 31 service centers which are available across the country. We also have one more solution called as Smart Fab or welded wire mesh that at times can save 30% of the steel and 70,000 rupees per metric ton. These are welded, basically not the rebars, but the micro-alloyed bars or the drawn wires which are welded together to provide you the reinforcement solution. And we can also provide you CRS grade of bars in this case. So manufacturing process is very simple. We cold draw, do the optional ribbing, and these are the machines which are used for electrically fusing the wire meshes. And these are available from 2 mm to 12 mm at diameter also 0.1 mm. And this can be used for various applications, and this is how we do the supply. Now, Tata Steel entered into a very important MOU with our partner InQuick, which my colleague Mike is representing today. I'll request Mike to take us through this great presentation on accelerated bridge construction. Over to you, Mike. Yeah.
Thank you very much. Thank you for the introduction, and thank you for your time here today. I will quickly run through our InQuick Bridges solutions that we've provided here and our work with Tata Steel that's ongoing here in India now. So infrastructure in India each year, the number of kilometres of road being built is increasing. The number of bridges is increasing each year too. And world record are being set on the amount of road being laid down and the amount of actual road being made. But the problem we have is if the roads are being made that quickly, we're not keeping up to the pace with the reinforced concrete bridges that we need to make the highways link together. So we have bottlenecks, we have stoppages, we have all sorts of congestion because the bridge construction methods are not keeping up with the roads. We have challenges through pillars sinking, through cracking, through heavy rain and weather events, through construction, and basically the system is not currently working the way it should be. And so in July this year, Tata Steel signed an agreement with my company, InQuick Australia, and we're launching a modular bridging technology. The system we have developed actually is a reinforced prefabricated formwork and deck panel segments that are made in a factory, fully quality controlled conditions. They're in a modular format, and we ship them out from the factory to the site where they're placed and poured. The system is IRC compliant, has been signed off, and it's quite a simple system, but very profound. So the segments are taken from the factory, they're placed in this location, and then simply the concrete is added on site. The concrete's allowed to set on the apartments, the decks are then placed, more concrete is added, and in the end you have a finished bridge system. This is an example of how the bridge system works and how simple it can be. The factory controls the production, placement of the parts occurs, concrete is filled, and the deck is finished. The advantage of this system is it's light, quick and simple. We only take about 15% of the metal weight in the bridge. 85% by the concrete is added on site. It's easy to transport. There's low to no maintenance in it because it's cast as a monolithic slab, so we don't have joints or bearings or tie downs to maintain. It's certified and durable. It's environmentally friendly and worker friendly because it's self-supporting and we don't have to get underneath the bridge and we don't impact the riverbed at all. Climate resilience, very strong. The bridges are resilient and they stand up to impact from the weather, weather events, from seismic events. And heavy rain and flooding doesn't affect these bridges. Our bridge solution has been recognised by the World Bank as the #1 solution for modular bridges throughout Southeast Asia. And when they employ bridges, they come to INCWIC for our bridging solution. The most exciting thing of all this and being here today is we're now starting to build these bridges here in Cuttack. This facility is under production and underway. I was out there this morning seeing how the bridges are being built and how they're being made. And you're more than welcome to come out and see how we're making them here on site so we can install them throughout India's road system. Thank you for your time.
So thanks, Mike. We are doing bridge construction in India using this technology in Cuttack, and I once again invite on the behalf of Tata Steel as well that you can come and witness the technology. This is my contact number, 90400 You just reach out to us, we will make all the necessary arrangement to arrange for your visit. Thank you so much. Thanks, Mike. Yeah.
Thank you, Prashantji and Mike. That was a very interesting presentation. Now, may I request Mr. Bharat to make his presentation on slim highway concept with precast concrete barriers from Messrs. Reblock Concrete Barriers Safety First.
Good evening, everyone. I'm Bharat Anand from Safety First. So we've all known that to build a slim highway, we need concrete barriers, right? But there's always been a big problem with concrete barriers that they're not flexible, and thus they provide too much impact severity to the passengers of the vehicle, and also during road building, the immovability of the barriers causes a problem. So this picture that we've got, the first picture that we've got is actually just depicting how the barrier is able to move out when there is a bridge pier in the middle, and then again it can come back into the median. So currently, our roads are occupying a lot of space, and now we are building more and more highways with, which are 6-lane, and even some of them have been designed up to 8 lanes, where we're taking up a lot of space, and it's obviously leads to a lot of climatic, the carbon footprint is very, very high. So when you build a slimmer highway which takes up lesser space, you reduce the carbon footprint, and the slimmer highway always also allows you to have increased number of lanes, reduction in land use, and obviously increase in road safety. So how can we redesign the cross section of a highway to be able to reduce the impact on the environment, right? So a modern vehicle restraint system which has a low profile but is at the same time tested and performance evaluated with very, very large vehicles and for passenger safety is one of the backbones of a slim highway construction. So the reblock concrete barriers that we are talking about, the biggest advantage of them is the coupler that you would be able to see in the inset picture on the slide. The couplers allow a little bit of flexibility in a concrete barrier, right? But at the same time, the concrete barrier remains connected throughout the length. And obviously the rebars are which take the energy when an impact happens, and that provides the safety. At the same time, it provides the flexibility which reduces the impact to the passengers in a vehicle. And this has allowed us to be able to construct barriers which have a capability of being able to contain even up to a 38-ton truck. At the same time, it has also been tested with a 900 kg car with very, very little deflection or zero deflection and very little vehicle intrusion. So these safety systems that we spoke about, they are tested as per the latest European and American standards, or even the Korean and the Chinese standards. So EN 1317 or MASH. And a slim barrier designed with low dynamic displacement and low vehicle intrusion means that you require very little space, and I wanted to showcase that with a few slides. So in a traditional highway, so this, I hope it's visible that on the extreme right of this image, there is a railway line running parallel to the highway. And for that, they have had to leave a lot of space to incorporate the deflection of a standard, say, metal barrier or any other kind of barrier that would have been placed there. And there's a lot of space which has been used, right? But in this same place, if we were to install a reblock system with its crash evaluated systems, you would be able to reduce a lot of space. And that's... Okay, sure, sir. So I'm going to skip that video because of shortage of time. But similarly, there's another problem that we faced with concrete barriers is the fact that because the impact with a large vehicle is so sudden that they tend to tip over the concrete barrier, and that causes a problem when there is something which is of high value, for example, a railway line, or there is a bridge pier, or there's a gantry structure which is present right next to where the barrier has to be installed. And for that, we've also got a design which is 1.85 meters tall, and it has a vehicle intrusion of VEI1, which means less than 0.5 meters of vehicle intrusion, and zero deflection when the barrier is impacted. But at the same time, the barrier has the capability of containing a 38-ton vehicle. So that's just a picture showing the installation of one such barrier right next to a railway line in the UK. And these systems can also incorporate noise barriers. They're tested with noise barriers. They're tested with gantry poles, light poles, fences, and all of these systems are tested with very, very high containment levels, which is up to the 38-ton truck. So there are various applications that can be made, and where you have wildlife passes, you would need fencing, or when there are pedestrians, you would also want fencing. Sorry, so I'll just wrap that up. Yeah, so I'm going to skip the video, but the integrated noise barriers with the openings. And this is a picture of the gantry pole being mounted on the barrier, and the barrier is tested with the gantry pole. The vehicle doesn't impact the gantry pole as well, right? So if you were to implement a slim road, if you were to build a slim road with a precast crash-tested concrete barrier, you would be able to save a lot of space, but at the same time not compromise with the passenger safety or the vehicular safety present. That's it. Thank you very much. Thank you.
Thank you. That was a good presentation on concrete barriers for slim highways. Coming to the next presentation, it is by Messrs. Honeywell International, Dr. Srinivas Cherukupalli. Reducing environmental impact in road construction, leveraging polymer modified bitumen to improve efficiency. Dr. Srinivas.
A very good evening, ladies and gentlemen. So this is probably the first time I'm between folks and dinner. So let me try and wrap it up pretty quickly. The topic of the presentation today is leveraging performance additives in polymer modified bitumen. And we'll just walk you through a little bit on the environmental impact that this can carry. So before we move forward, I just wanted to share that Honeywell Advanced Materials is now Solstice Advanced Materials. It still carries the same legacy of over 130 years of performance additives and materials and a lot of well-known brands. So please visit us at Solstice booth at the exhibition. So just a quick outline on the presentation. So we'll talk about performance additives, their chemical structure and how they lend properties to PMBs. The impact on energy consumption, will present bits of the life cycle analysis that has been done. And finally, performance metrics, which my colleague Swapnil will be able to handle. So from a mechanical response point of view, if you look at the loads that are put on any pavement construction, it varies between tensile, shear, elongation in some cases, or even compression, right? So the way the road responds to these stresses is through absorption and then releasing it as part of the strain. Different materials respond to these stresses in different ways. So if you have typical rigid materials, you'll see the straight line onto the left one in the middle graph. So it's got a good amount of stress that it can take, but it doesn't have enough strain. So these rigid materials tend to crack pretty quickly. If you have an elastomeric material, it can take a lot of strain before it picks up. This strain is pretty much recoverable in most cases. In between these two is a plastomer. So it acts as an elastomeric material till it reaches a certain point, which is the yield point, and beyond which it then has a non-recoverable strain. So that's the way these materials function. And let me just go into a little bit on what we see in the market, how these materials are presented, right? The primary role of a modifier is to enhance the properties of the PMB. And it can do this by creating either a physical or a chemical network. If you have an elastomeric material such as SBS, you have the styrene, butadiene, you have the carbon double bond, carbon bond upon which you can have a lot of flexibility. That's where butadiene plays a role. And this double bond can be broken. You link it up with sulfur and thus create a chemical reaction-based crosslink. Same thing in terpolymers, where you have a very strong reactive epoxide group on the top right-hand corner. And this ring is always trying to find a positive ion or a hydrogen to bond to. And the moment it sees this ring opens up and it starts a reaction going on. So these materials, as you can see, have aromatic rings. They're pretty complicated in their structures. And what it does is it actually creates an amorphous kind of a network. So amorphous, you can imagine like, cooked Maggi, for example, the change going all across. Now, if you come to plastomeric materials, let's say if you pick polyamides, for example, you have the carbonyl group, C double bond O, which helps to bond it to the bitumen components. And the polyethylene based, you see on the top right-hand corner on the right side, ethylene vinyl acetate. Then you have at the bottom, which is nothing but a base polyethylene, basically waxes, where you have ethylene molecules up to, let's say 20 molecules linked together. So that's a molecular weight of, let's say 500 or 600 gram per mole. In between, you have what is Solstice Titan. And you see that the structure is much simpler It has the alkyl groups linked together, which helps it to blend well with bitumen. But it also has a carbonyl group, which helps in creating a chemical network. So the reason why the physical network is important is because it creates a crystalline network. Instead of having spaghetti or Maggi going through together, you can think of these as matchsticks lined up one after the other. So this creates a much more stiff and stiffer structure and helps in physically bonding through the bitumen. On the other hand, you have, like I said, an alkyl group and a carbonyl group which helps it to chemically bond. So that way you have a functionality which is both physical and chemical, lending it to be much more an optimized solution. If I look at, let's say, without the FTIR, you have the allotments on the functional groups. But on the right-hand side, you have DSC, which shows the range of temperatures that it can be working around. Again, with PMB, what we see as an advantage is the increase in softening point with increasing loading, but there is no change in terms of the viscosity that happens when the loading is done. So that's the beauty of it, when you probably don't want to have highly reactive systems in place because they may react fast, but you tend to be careful with regards to the workability of these solutions. So in few minutes, I'll just present how this the structure lends itself to life cycle analysis. And in this case, a much more detailed one, we went from cradle to use. That means we take all the raw materials that are input into the system and all the way till the payment is done, right? So the goal and scope, there are 4 phases in a life cycle analysis. You have the goal and scope, you have the inventory, which is the most important piece where you collect all the data. That itself has taken us more than 3 months to get through along with customers who helped us. You have the impact assessment, which then give you global warming potential, all the different elements of a life cycle assessment. And finally, the interpretation, how do you want to continue on this? So I'll not go through too many details on the scope, but you just have to know that these are done as per ISO standards. And on the cradle to use, there are 2 states which are presented. One is with Solstice Titan, and the second is with the next best alternative, both mixed at the PMB stage. The system boundary, like I said, encompasses all the elements from making the raw materials till the end of making the pavement. I don't have to go through the process flow. I'm sure pretty much everyone knows this. And all the questions and the data that goes into this process flow are taken into the life cycle inventory, which is the most important one. Once the inventory is completed, we use SEMA Pro software and EcoInvent as a database to then create the impact assessment. So this is literally a network diagram for how Solstice Titan walks from the way, using natural gas to create Titan from start till the time it is used with bitumen in pavement. From a potential global warming potential on a 1 metric ton basis of asphalt, we have seen Titan at 47.2 kilograms of CO2 equivalent versus 54.4 CO2 equivalent for the next best alternative. This itself is about 10 to 13% benefit. If you do it at a 1 kilometer level, wherein you have all the impact categories listed out here, and the number for global warming, which is around 63 tons for Titan, and that goes to around 73 tons for the next best alternative, which is again a 10% delta with regards to the life cycle analysis. So you have a structure which is optimized, you have a process which is known, and then you result in a life cycle analysis which is much more beneficial, which is the future of the industry, I would believe. So with this, I just wanted to give you a heads up on how impactful this is. On a kilometer basis, you still have 2 automobiles off the roads, saving around 3,000 liters and reducing almost 3,700 kgs of coal. So it's quite an impactful journey that can happen with Solstice Titan. So I'll just have a few performance studies to complete, and that will close the presentation.
So thanks, Srinivas. So I'm Swapnil. So actually, Srinivas talked about, that what is the material, what we are using, and also how it helps in carbon emissions. But at last, the thing comes that what is the performance of the material actually. So I'll talk about some of the case studies and also the performance, what we have done. So this is the first one actually. We have done some NSV survey on the sections, what we have done. So we have laid 2 sections, that is, one was with Honeywell Titan, the other was with a hybrid solution. So hybrid, I'll talk about, we have done a combination of, elastomer with Solstice Titan. So if you will see in the fatigue life of this, on the same stretch, the fatigue life is almost the same as we see statistically. There is no difference between the fatigue life of the stretch actually, if we compare Solstice Titan stretch with the hybrid solution. So if I move on to the rut properties actually, so in terms of rut lane also, you will not see any performance difference. They are almost similar in terms of performance. As well as it is same for the IRI, that is the roughness index, what we see. But if we move on to that is SMTD, that is sensor measured texture depth. So you'll see the two circles rounded there. The first circle states the Titan, Solstice Titan stretch.
Mr. Swapnil, please wind up within a minute.
Yeah.
Within 1 minute.
We'll just finish. I'll just talk about a case study that was done in BRO actually. So it was laid in a section which is somewhat around an altitude of 17,000 feet with a temperature difference of 35 to minus 25 degrees Celsius. And we have received an official report from Border Road Organization on the performance of the report that it's working fine and it's good to go. And these are some of the footprints across India, what we have done across India and many more across the globe also. And with this, I conclude that, with the Solstice Titan has a unique chemistry to go for the PMB modified. Also, it helps in lower energy consumption during the pavement constructions and with high performance road at the end. Thank you. And the Q&A continues at the booth. Please let us meet at the booth at 162.
Thank you.
Thank you.
Thank you, Dr. Srinivas and Shri Swapnil. Now I invite from Messrs. Tikitar and Shell India, Shri Niranjan Sarkar and Shri Sumit Gudesar on long-lasting flexible pavement assets.
Mr. Chairman, Mr. Co-Chairman, dignitaries on the dais, ladies and gentlemen, it's my great privilege to be here with you, and the previous presenter, Srinivas, he has set me up very well for the sustainability-based approach, which I'll talk to you about. So just a quick one, safety and health. In case there is any fire alarm, please reach out to the exits. Don't listen to me. I can make this presentation again. Quickly, Tikitar and Shell, we are here pioneers in the bitumen industry, 6 decades of experience, very amazing projects we have been privileged to work with. And what is our area of interest? So if you look at our area of interest, we are into very, very bespoke engineering PMB. We are 50. At 1950, we were at 4 billion people. Today, at 2050, we'll achieve 9 billion. 2 billion of them vehicle users. And we have some sobering statistics with the CO2 equivalent, etc. At the same time, if you look at our sustainability ambitions, when I say ours, India's sustainability aspirations, we have taken targets of 45% GHG decrease per capita of GDP by 2030. These are very big targets for a country like India. And if I look at what sustainability means, the best definition we could get, the UN Brundtland Commission, meeting the needs of the present without compromising the requirements of the future generations. Now, how do I tie it up with pavement construction and in specific flexible pavement construction? Okay. Now you look at building and construction. 37% of the global CO2 equivalent emissions are coming from this. And traditional pavements, if you see, they will use virgin aggregates, bitumen, steel, cement. Some of these are in the hard to abate sectors. It's not really very easy to find replacements for these. And if we look at very clearly in the flexible pavement context, if you look at environmental benefits, there are many, supported by both economic and social benefits. Look at social benefits like safer roads, comfortable ride, less noise, community friendly. These are things we need to aspire for. That's why this session is not about selling any, I'm not trying to promote any product. I'm just calling all stakeholders to collaborate and create more sustainable road infrastructure for India. Now, if we look at, for example, sustainable flexible pavements, okay, we have to move very clearly, like the previous speaker spoke about LCA. So we have to move from something like a design, use, rehabilitate to something like a design once, maintain forever. Think about it, okay? Design once are used, tried and tested technologies, not that we have to reinvent the wheel. Similarly, a very nice technology has come to use in India for the last couple of years. Look at stone matrix asphalt or stone mastic asphalt. Excellent mixture for perpetual or long-lasting pavements. Now, for that, we have to have very specific PMBs, okay? PMBs, you look at stone matrix asphalt. Everybody talks about stone-on-stone contact. So imagine what little stone-on-stone, in the stone-on-stone contact, very little coverage of bitumen is there. So for that, you have to engineer the PMB. You cannot use a certain grade, 76E minus 10, 82E minus 10, no. Engineer it for that purpose. Similarly, when you engineer it, it should be very relevant with what we are doing now. You can't make a PMB and say, oh, my PMB requires special storage conditions, special this, changing the full industry. We go with what we have. Similarly, PMB, now new trend, loading more and more polymer. That's a very sophisticated game. You look at this plot, come to my stall, we'll have more discussion about it. I have a time constraint here from Chairman's Hub. You look at these two figures, they have the exact amount of SBS in them. But look at how different they look in under the UV microscope. So simply loading polymer, not a solution.
Niranjan ji, I think you should give some time to Shri Sumit Gude sir also. He will be speaking?
No, sir.
Okay, only you will.
Thank you, sir. Okay. Thank you for the intervention. Similarly, look at this simple notch, okay? That single notch is the ideal zone. And today, do we really need to be constrained with just doing a 2-day softening point after the tube test? There are few tests which MORTH already mandated DSR. We can use some of these techniques. And some super heavy duty PMBs, it's not that they are something of the future. Look at this, it's already here available to whoever wants to use. And again, see, when you use a PMB, sometimes you may think that, we are using polymer, it has a high carbon footprint. No, it has a high carbon footprint, no doubt, but do a cradle to grave analysis. See how many more years, how many less maintenance interventions we require. Similarly, other concepts, like I heard many people speaking about less noise. Use like OGFCs, double layer of OGFC with specially made PMB, almost noiseless pavement. Colored bitumen, less, you require much less lighting in enclosed spaces like tunnels. At the same time, just wanted to build a small dichotomy between resilience and sustainability. They are quite different, okay? And there are some requirements.
2 more minutes.
Oh, I won't require, sir. There are some requirements. See, when we go for sustainability, we need to willingly accept higher initial investments. We need to look at non-standard materials. We need to invest in labs. And at the same time, enablers like knowledge dissemination, this platform, similar platforms, pilot projects. So to conclude, sustainability, we have to go through all stages of the project. So we have to think in the life cycle, not just one initial point, okay? It is very, very innovation driven and very context specific. An innovation or a context here will not work, for example, in Rajasthan. So I also invite all of you to continue the conversation in stall 97 and 98. And thank you for your time and to hear me out on behalf of my team. I thank you all. Thank you, Mr. Chairman.
Thank you, Mr. Sarkar. I must thank all the presenters for keeping strictly to the time limits. I will quickly invite Shri N.K. Panda, Managing Director, India and Nepal, Mrs. McAfee Environmental, for his talk on green solutions for soil erosion control. Shri N.K. Panda.
Thank you. Good evening to all of you. So I'm talking on a topic called green solutions for soil erosion control. Quickly, 1 minute about McAfee. We have been here for last 140 years. We are a leading international provider of advanced solutions to the civil, geotechnical, and the environmental construction market, starting from retaining walls to hydraulic works to rockfall mitigation to soil reinforcements. We are providing a lot of solutions, both here, India, and globally. I'll quickly talk about, the geosynthetic solutions for roads. This is a quick diagrammatic representations of embankment and the slopes. If the soil erosion is not taken care of, then it leads to this gully erosion, this kind of soil erosion. And in this case, the slope has to be treated. Now, the factors obviously which are responsible for this erosion is runoff water, especially during monsoons, and after monsoon you see this, strong winds and human intervention. So how it can be treated? We all know that there could be erosion control products, and along with that vegetation can solve this soil erosion. So this is a quick example of how this can be treated using the erosion control products, and on top of it, how you grow the vegetation. Obviously, all these solutions are covered by the codes and the guidelines, namely RDSO, IRC 56, IS 15872, and MOT guidelines. Now, maybe I would like to highlight a relationship between the erosion control products or the erosion control mats that we spoke of and the vegetation growth. So my topic here, quickly I'll be touching upon this, impacting factors of vegetation on this erosion control products, right? So we went to Professor Biscetti, who is the head of Department of Agriculture in University of Milan, we being headquartered in Europe. Obviously, we chose this university. And why Agriculture, Department of Agriculture? Because vegetation is obviously within the ambit of agriculture, and hence we chose this department where we did this study. Obviously, for this vegetation or the revegetation, right, there are two basic factors. One is the product which goes onto it, which is the erosion control product.
Just a minute. May I request the organizers to please shut off these lights? They are disturbing. Thank you. Please continue.
Yeah, it's adding a factor to the presentation, looks like. But yeah, the second part is the site-related factors, right? Because ultimately this erosion control product is to put on the site. There were 7 parameters which were identified, which were researched for the product, and 5 parameters for the site-related, right? The 7 parameters of product are basically what kind of light penetration the product allows, what kind of thickness of the product, what is the color of the product, what kind of water absorption the product has, what is the weight, the runoff or the roughness of it, and the uniformity of the product. Obviously, in terms of site-related, it is albedo, what kind of reflection the site has, the plant growth capacity, the soil humidity, soil temperature, and water runoff. Not getting into too much of details because of the time constraint, but these are the 2 parameters between the product and site-related where the research was done. Now, before I come to the results of this research, there are different product categories on which this research was done. Basically, it is, for this erosion control product, there is a biomat, geomat, composite, and geotextile. And this is the result of it. This is called a graph, where if you see the higher the area of this graph, the better the product performance is. And if you see the better performance is for geomats as compared to biomat, geoblanket, or composites, right? Obviously, all these parameters are mapped for this particular product, and clearly geomat is a far better product as per the research. Now, McAfee has its own geomat called MacMat, and all these performance parameters were again studied beyond the MacMat. And of course, there are 2 parameters also, the weight and the color, which can again be taken care of by changing the color aspects of the weight through our MacMat steel. And using this MacMat, it can have a high graph because of which the product performance is high. So quickly, this is a sustainable solution for erosion control. And again, a different test was done using the Russell equation, which again tells about the superior performance capability of this product. These are the 2 case studies which were done in the Gandak River bank in 2021, which again proves the success of the MacMat, and the railway embankment in Rajasthan, which was done. There are multiple use cases, but I just chose 2. And quickly, this is how the site was.
One more minute, please. One more
Done.
minute.
Thank you. This is how the site was before this product was deployed. You know, this was completely arid with a lot of erosion issue, and this is what it was post the, MacMat was deployed in this particular site. So of course you see that this has a very, very high, performance characteristics, and it is highly recommended to use for soil erosion in terms of the, in those embankments where there is a lot of soil erosion happening, right? So with that, I conclude my presentation. Thanks a lot. Thank you, everybody. Thanks a lot.
Thank you, Mr. Panda. May I now invite Shri Chetan Pawar from Messrs. Power Arch Innovations Private Limited for his presentation on the new era of cost-effective and fast-track bridge construction. Shri Chetan Pawar.
Thank you. Namaskar. Myself Chetan Pawar, representing Power Arch Innovations. I will quickly go through the slides. Thank you. This is what 150-year-old structure looks like. These are really inspiring structures. They don't require any kind of maintenance, no bearings, no reinforcement, no expansion joints, nothing. And they are still standing strong. Designed for 8 tons of load and carrying more than 70 ton or 80 tons every single day, no distress. And still we are not building those. I always think why we are not building arches anymore. So the core of Power Arch Innovations, we are basically fascinated and passionate about arch bridges. What we do at Power Arch is research and development, analysis and design, and DPR preparations and construction as well. So we have a couple of products in our kitty. The major is the Super Arch, which you can look here. Another is Super Duct, and then Power Arch. We have in-house material testing, load testing facilities. We are based in Nagpur, by the way. So what we do is we are expert in analysis and design of the very complicated structures like arch, and that too without any reinforcement. So this is PCC structure. So you can see the analysis of the arch. This is for the analysis of Super Duct. This is FE analysis conducted in ANSYS. We also do DPRs for the arch bridges and the project what we construct and the construction of the arches. Now basically let's have a look at what is Super Arch. So this is recently we have completed this bridge like 3 years ago. This is completely PCC bridge. This is completely new bridge. No bearings, no steel, no maintenance. Another PCC bridge for the irrigation canal in Maharashtra. Same here. This is for the national highways. We are doing on the express highways and national highways all over India. This is submersible. We can build like submersible bridges, high-level bridges, all sort of bridges. So the first question is, what is the advantages of implementing super arches? It's cost effective, the most important thing for any client or the contractor or the government. It's cost effective, at least 7 to 10% reduction as compared to the RCC bridge. There is no structural steel, there is no bearings. It is for the highest standard of loading as per IRC 6 for 70R. Zero, literally zero maintenance for these bridges. And it's a fast construction. The bridge we are looking at can be constructed within 6 to 8 months. The lowest span we can go for is 10 meters, the maximum span we can go for 25 meters, and multiple span we don't have any kind of limitations. Okay, so this is how those arches reach to sites on a flat bed trailer. Once we lift it, we just have to place it on the sockets, like on the top of the abutments or the PS. Every individual arch strip is 1 meter wide. So look at this process again. That 100, 150 ton crane is lifting that arch. That arch is flat at the beginning. Once we start lifting it, it starts a shape, the arch shape. So once we attained complete arch shape, we tied that arch from both ends at the bottom and place it on piers or abutments. By the way, the piers and abutments of this bridge, the foundation of this bridge, everything is PCC, plain cement concrete. I will have to skip this video, otherwise it will take time. So I hope you understand the procedure. So like this, it lifts like this. We have to maintain the shape of the arch by operating those chain pulleys on the left hand side and the right hand side. Every single day we can place 8 to 10 strips easily. By the way, this was the project for the national highway and the span was 15 meter. Single span was 15 meter and the carriageway was 16 meter. So total 15 strips we have placed here. I will skip this one now for the next slide. So this is super arch. Once we place the all arches, we will fill those arches using the stones, rubbles, okay, like this. So 70% will be the stones and 30% will be the lowest grade of concrete like M7 or M10. So this is called plum concrete, 70% plum and 30% concrete. Once we finish that, bridge is ready. So how this arch strips works? These are the concrete blocks which we use for making of strips. This is PCC. Whatever reinforcement you're looking at is just for the lifting purpose. That is not structural steel. We place it in one line. We connect those using the steel metal. That is also temporary, by the way. We remove this once the arch shape is take place. Then we half lift this. I will just skip this video. You have seen already this one. Okay. Then we full lift, place it on the foundations, you have seen, place it on the piers, place it on the abutments, and the bridge is complete. We have also done cut and cover tunnels in Himachal Pradesh and Ladakh. This is how it looked like. The filling above the arch was 40 meter. We have also completed tunnel for border road organization. This was in the Himachal Pradesh, and this is in the Ladakh. So this is what the super arch is. I will quickly go with hardly a couple of slides. What is super duct? So this is what the duct is. We are fascinated with the arches. So this space, this shape is also in arch shape. This is what the super duct is. It is basically replacement for the box culverts and the pipe culverts. It looks very small, but this is basically 3 radius duct. This is what the actual size of the duct are, right? The biggest one, T9, the LMV can pass through the T9. That is what the size of this. So these are the sizes. The smallest one is 2.25 meter and 1.36 meter. I will skip the dimensions. The biggest one is 4.3 meter span and 2.7 meter rise. The same thing I have shown here. If you want to replace 2 by 2 meter box, we can go with the T5. If you want to use 3 by 3 meter box, then we can go with the T9. Construction and the manufacturing is very simple. These are steel molds. We place little reinforcement, 10 mm, nominal reinforcement. We put concrete of M30 grade, remove from the mold, cure, transport on the side. Only excavation we have to do, we don't have to go with any kind of PCC or any bed making. Just we have to compact whatever soil is there. It is better if it's a black cotton soil. It performs well. We just have to place it, fill it with any material, soil or morum or GSB or 10 mm aggregate or suri or whatever, okay, or dust even. We just have to fill it.
One more minute, please. One more minute.
This is last slide. So we just have to fill the arcoducts like this and complete the head walls, and we can start the traffic. These are a couple of projects, single arcoduct or multiple arcoducts. So this is how it is. We have already approvals and technical papers published for the arches as well as arcoducts. Currently, this is in development process. We are planning to introduce the head walls for the arcoduct so that we can complete this project within 24 hours, from excavation to the filling of the arches and making of the head walls. These are some awards. Again, we are fascinated by this shape. This is 120-year-old bridge, standing strong. This is in Satara, near Pune. And this is real inspiration. Don't know who built it, but still it is strong, like standing strong. Proud of my site team, my research team. Thank you.
Thank you.
Thank you. Thank you. Thank you very much.
Thank you, Chetanji, for your very interesting presentation on PCC arches. Now I invite Professor Shyam Ravindranath from Messrs. Jalnidhi Bitumen Specialties Private Limited for his talk on polymer modified bitumen solution for optimum road performance.
Good evening, Chairman and Co-Chairman and all audience sitting here. So my name is Shekhar Vani. I am Technical Head of Jalnidhi Bitumen, and this presentation is joint presentation with IIT Roorkee with Professor Shyam. So Jalnidhi to deliver better world. So we are at Jalnidhi. We have very strong team, and we do the innovations and continuous research and development. And we have a professional teamwork. That's how we work. So we have 2 factories and office at Delhi and Kolkata. And this is our growth. Like we started with 304 crores in 22-23, and now at 24-25 we have 525 crores. So these are our certifications, like NABL, ISO 9001 and BS license for modified bitumen. So now request Dr. Shyam Sundar to take over the presentation.
Okay, so good evening everyone, and thank you for this opportunity. So when we talk about polymer modified bitumen, the first word that comes is polymer. So as a general knowledge, the word polymer comes from the word poly, Greek word, which means many, and the mer means units. So polymer is combination of many units. So that's how the word polymer has come in. And it is obtained from the polymerization or the synthesis or chemically covalently joining many units monomer to get a big molecule. So is the polymer very rare? No. In nature there are hundreds of polymer around us. Cellulose, lignin, DNA, RNA, our hair. So hundreds of biopolymers are available and we see day to day. Similarly, there are hundreds of man-made polymers which are called synthetic polymers, which we use regularly. So now the question is, why do we use hundreds of different polymers? Because each polymers have a specific property and they are suitable for a specific application. And even minor fine-tuning of the chemical structure. Because of this, polymers are widely used everywhere. Even fine-tuning of the chemical structure, let's say from LDP to HDP to LLDP, the chemistry of the polymer is the same. But just fine-tuning the chemical molecular structure, we can change the practical application of the polymer from a film to a hardcore product. Similarly, from rubbers, by minor tuning of the side groups, we can change that from a rubber to a thermoplastic polymer. So this is the benefit of polymer, and that is why it is so successfully used every day, everywhere. So now coming to the payment industry, the most commonly used polymer is SBS polymer. Nearly 80 to 90% of the polymer that we use for bitumen modification is SBS. So why is that? Why is that? Okay. Okay, because see, if you see, there is styrene units at both the ends, which gives stiffness, which gives the load carrying capacity to this polymer. And in between there is butadiene unit, which is a very rubbery like flexible molecule, which gives elastic recovery properties to our polymer. And in between you see a double bond, C double bond C. This acts as an interacting group using which the polymer interacts with bitumen. So any polymer that we use for bitumen modification should have these 3 characteristics, it should have stiffness, it should have flexibility, and it should have a chemical group that it interacts with the aggregates, it interacts with the bitumen molecule. Because of which 80% of the polymer that is used for bitumen modification is SBS. So coming why it is so successful. So if you see this plot, this is a plot of softening point versus SBS concentration. So softening point generally reflects the load carrying capacity of our bitumen. Here you can see that with increase in SBS dosage, the load carrying capacity of the bitumen increases. But the most important point that I want to mention in this presentation is beyond 3%, if you see beyond 3%, the increase in softening point increases very significantly. It is like a flight taking off. So you need minimum 3% SBS for enhancement in properties. Above 3%, the enhancement in property is very, very significant. And why is that? Below 3%, if you see in the graph, in the SEM image, the polymer is distributed far away from each other. But with increase in SBS dosage, the polymer forms a network-like structure, a flower-like structure. And because of which the load carrying capacity of the SBS modified bitumen increases enormously. With further increase, with further increase in the polymer, the load carrying capacity further increases. So if you see this plot, this is the most important plot for a polymer modified bitumen. Beyond 3%, the property enhances, and around 5 to 6%, you get an optimum value of the properties. And above 7%, there is not much enhancement in the properties. So is this trend observed in different bitumen? Yes. Irrespective of the type of bitumen that we use, VG10, VG30, VG40, imported bitumen, the same trend is observed. That means the load carrying capacity increases above 3%. And if you see that plot on your right, the phase angle value decreases with SBS dosage. That means the elasticity in the bitumen increases, and that also reaches an optimum value around 5% dosage of SBS. Okay. So, but that is in bitumen. Will that reflect in the mixture performance? So this is a plot of rut depth versus the cycle of loading in wheel tracking. Here you can see that the black data is for VG10. With 3% SBS, the rut depth reduces. But the rut depth reduction is most significant when you reach that 5% loading of SBS, around 4.5%. And beyond that, the rut depth reduction saturates. Similarly, not only rut depth, the fatigue cracking is also a very important parameter that we have to consider. Here you can see that the black curve is for VG10, but with increase in SBS dosage around 4.5%, the fatigue cycle increases 10 times and
Please
the rut
conclude.
depth decreases by 50 to 70%.
Please conclude, sir.
Okay. So I'll skip all this. So coming to the conclusion, around 80 to 90% of the polymer that is used globally for bitumen modification is SBS. Above 3%, the property enhances. Around 4 to 5% optimum dosage is reached. And in India, there are roughly 4 different main type of polymer that is available. My recommendation is always use PMB 82E-10, irrespective of is it BC layer or is it DBM. And why is that? So in the title you saw this number 90-90.1. What is that 90-90.1? That is a PMB which has a softening point of 90, elastic recovery by ductility of 90%, and JNR value close to 0.1. That will be the best bitumen to be considered always. And though the cost of the bitumen increases by 5 to 7% of the overall project cost, but the life cycle enhancement is very significant. So that's why I recommend this not only for highways, but urban roads and even for rural roads. Okay, I would like to stop here.
Thank you.
Okay, thank you.
Thank you, Professor. May I now invite from Messrs. Secura India Management Limited, Dr. Gurunath Guduru and Mr. Sandeep Das. Dr. Gurunath will be speaking or? Okay. And Mr. Das will also be speaking?
Only myself.
Okay.
Hope I am audible to everyone. So, good evening to one and all. Myself, I am Dr. Gurunath, working as a manager at Secura India Management Limited. So, before going to start the presentation, a small intro about our company. So, we, Secura India Management Limited, the concessionaire involved into the operation and maintenance of the highway assets. Currently, we are having 15 highway assets across 12 states covering a length of approximately 4,600 lane kilometers. So, today we will be discussing about some of the best practices that which we have used for the adoption of the sustainable materials in our project sites. The first one will be the wrap material, the second one is the steel slag aggregates, the third one will be the asphalt reinforcement. So we all know that utilizing wrap material can lead to the environmental, economical as well as the sustainable benefits. Still we are using wrap material at a lower content in the bituminous mixtures. These are some of the limitations which are limiting the usage of high wrap content. The first one is the variability in the wrap characteristics. This can be addressed by fractionating the wrap material into different fractions, that is coarse and fine fractions. The second one is the selection of the optimum regenerated dosage. Generally, the regenerated dosage will be selected based upon the target bitumen properties, but it should be selected based on the control mix properties. The third one is the risk associated with the performance of the mixes with high wrap content. To overcome this issue, we need to adopt the balanced mix design approach. The fourth one is related to the plant-related aspects. That is where the regenerator needs to be added, what should be the mixing sequence to be adopted, and the cycle time needs to be maintained for getting the good quality of the mix. The last one is the lack of quality control test. The conventional quality control tests that are adapted for the conventional bituminous mixes are not sufficient for these special mixtures. So we need to go for a performance indicators where we can evaluate the consistency as well as the quality of the mix. So we have utilized the wrap material in one of our project sites in the state of Gujarat, where we have used wrap material in DBM as well as the BC. In DBM, we have used wrap material from 35% to 45%, whereas in BC, we have used 20%. We have used wrap in BC1 as well as the BC2. So for the design of these recycled mixes, we have adopted balanced mix design approach A, that is volumetrics design with performance verification. So compared to the conventional method of determining the regenerated dosage based targeting to the control between properties, in this particular project, we have used a new approach, that is coefficient test for the determination of the regenerated dosage. The applicability of these tests for the determination of the regenerated dosage was summarized and presented in the previous IRC sessions. So the same findings were utilized in the present project, and we have determined the regenerated dosage for the designing hot recycled asphalt mixtures. The test is very simple. It can be carried out with the basic Marshall apparatus that is available at most of the field laboratories. Being the simplicity of the test, this particular test can also be used as a quality control parameter for optimizing the regenerated dosage in the production of the recycled mixes depending upon the wrap characteristics that are prevailing at the site. So after evaluating the optimum regenerated dosage, we have used balanced mix design approach for designing the recycled mixtures. Once all the volumetrics are satisfied as per the MORTH requirement, we have done the performance evaluation against the fatigue rating as well as the moisture damage, and we have compared the recycled mixes with that of the control mixes. You can see the performance against fatigue rating and moisture damage of recycled mixes are close to that of the control mixtures, which shows that the recycled mixers can perform equivalent or at par the control mix. So once we have done with the design at the laboratory stage, now it comes to the execution stage. So we need to decide where the regenerator needs to be added in the hot mix plant for the production of the hot recycled asphalt mixtures. There are three possibilities where we can add the regenerator in the hot mix plant. The first one is the bitumen tank, second one is over the conveyor belt, the third one is the pug mill. Among the three possible options that are available, the best and most effective method will be the addition of regenerator directly in the pug mill. So this is the most effective method where all the regenerator can be effectively utilized by the wrap material. Once we have decided where to add the regenerator in the hot mix plant, now it comes to the mixing sequence. What is the mixing sequence to be adopted for mixing different proportions in the hot mix plant? Among the two methods that are mentioned here, the second one is the most appropriate. That is, first we need to add the wrap material, then followed by the regenerator, so that all the regenerator will be effectively utilized by the wrap material, then followed by the superheating aggregates, then dust filler, lime, and last but not least, fresh bitumen. So this is the methodology approach we have adopted for production of hot recycled asphalt mixes, and we have used DBM, 35% to 45% of RAP, and we have executed a length of around 32.365 kilometers, out of which 32 kilometers was executed with 35% of RAP material. To evaluate the performance of mixers at higher RAP content, we have also done 40% RAP for a length of 155 meters and 45% for about 210 meters. We have also used RAP in the BC layer for a length of around 18.5 kilometers, out of which 1.5 kilometers was constructed with the BC1 and rest was with BC2. So this is the typical layout of the HMP plant, which we have used for the production of the hot recycled asphalt mixes, where you can see the screening plant is there, and the coarse RAP on a hot RAP was separated, and the regenerator was added directly into the pug mill. So it was executed 2 years ago, and we have collected 2 cycles of performance of the data, and we have compared the performance of the RAP mixes in DBM to that of the conventional mix without RAP material. Similarly, BC with RAP without BC, conventional mixes. Similarly, RAP in DBM and BC was compared to that of the control mixes. It can be seen that the central deflection value of the FWD is less in the most of the cases when compared to the control mixes, which indicates that the performance of recycled mixes can perform equivalent to that of the control mixes. So based on our practice, actually, these are some of the recommendations which we are suggesting for the field practitioners. We have categorized these recommendations into 2 categories. The first one is prior to the mix production, and second one is during the mix production. Prior to the mix production, the RAP characteristics of the individual stockpile needs to be checked ahead of the mix production. The second one is conducting the coefficient test to vary the regenerator dosage depending upon the RAP characteristics that are prevailing at the site. The third one is adjusting the superheating temperature. Okay, sir, I will be taking 2 more minutes. So adjusting the temperature of the virgin aggregates based on the moisture content and RAP material. Finally, we also need to conduct the quality control test. The second sustainable material which we have used is the steel slag aggregates. So these particular steel slag aggregates are being used in our in the state of Odisha, where we have used steel slag aggregates in the DBM layer, and we have partially replaced 48% of steel slag aggregates with the natural aggregates. The problem which we will be getting with usage of the steel slag aggregates is the expansion characteristics. So in order to determine the compounds that are responsible for the expansion characteristics or the CAO and MgO content, we have carried out the XRD as well as the XRF. From these 2 tests, actually, those proportions are very less in nature. So further, to ensure, we have also carried out the expansion ratio for different aggregate fractions. Out of all the 3 fractions, actually, the 20% 10 mm aggregates, we are getting an expansion ratio which is less than 1%, prescribed by the FSWA guidelines. And we have used only coarser fraction of the steel slag aggregates, and we have carried out the balanced mixed region approach. And these were the findings. You can see that fatigue performance of the steel slag mixes are equivalent to that of the control mixes. So far, we have executed 23 kilometers of DBM with 48% of steel slag aggregates. These are some of the recommendations which we are recommending for the practitioners. Just I will be taking 1 more minute. So one more sustainable technology which we have used in our ongoing project sites is the asphalt reinforcement. So asphalt reinforcement will act as a stress absorbing member placed in between the 2 asphalt layers. It will control the reflective cracking, thereby extends the pavement life and improve the fatigue performance. Research studies shows that thin asphalt overlays with asphalt reinforcement can perform equivalent to that of the thick asphalt overlays. So prior to using the glass grids in the site, actually we have evaluated the performance of the mix against the fatigue performance with and without the glass grids, and it was showed that there was an increase in the fatigue performance of the mixes reinforced with the asphalt layer. Improvement was there 2 to 2.5 times. So far we have utilized the glass grid in 3 projects. Currently we are using in Sambalpur Rourkela project. So this was the field performance. You can see that the performance of the mixes reinforced with asphalt are showing better when compared to the control mixes. So we would like to acknowledge the support of the Payment Engineering Division of IIT Kharagpur, Flexible Payment Division of CRRI for their support in the successful implementation of the sustainable technologies in the projects. And we would like to thank GSRDC and Odisha government for allowing us to use these sustainable technologies in our project sites. Thank you.
Thank you, Dr. Gurunath. Now may I quickly invite Mr. Parikshit Gaur of Utkarsh India Private Limited for his talk on reimagining road safety, tested strength, digital traceability and smarter infrastructure. Mr. Parikshit.
Good evening, everyone. I'm Parikshit Gaur from Utkarsh India, and The topic is reimagining road safety with tested strength, digital traceability, and smarter infrastructure. Before moving forward, I would like to introduce ourselves. So we have 40 years of industry experience serving diverse sectors such as infra, power, telecom, water, and agriculture, having a skilled workforce of 4,000 plus employees and a revenue of 25,000 crores. We are the largest crash barrier production capacity in India. We dispatch around 500 kilometers of road safety systems every month. So this new product is about a solution for dead investment. So when we are putting up a safety barrier, it is a dead investment because it is not generating any revenue for the government. So we propose a new system having a crash barrier integrated with advertisement panel. So what it does is, it is a trusted design. The design is already, the base design is already crash tested, and the complete new design is simulated at the government lab. It stops the unauthorized crossings. So pedestrian crossing in the medians acts as a very, is not a road safe arrangement. So and third thing is it generates revenue for the government through the advertisement panels. And fourth, it improves the night visibility. It stops the median glare. And here are some of the features and comparison with the conventional barrier. So both the barriers stops the vehicle, contains the vehicle. With the pedestrian management, the conventional barrier does not offer any solution as people tends to jump over it. But with our new smart system, it is very difficult to cross over. In terms of revenue generation, the new smart system is an advertising-based model, hence it will be a value-generating asset for the government. It looks good and it stops glare reduction. So moving on to the next topic, which is quality control. So there's a new term called factory production control. So Utkarsh India Limited is one of few Indian manufacturers with CE marking and FPC certification. So crash testing proves the design, but what FPC does is it ensures that every barrier that is going to be manufactured tomorrow performs the same as the one tested yesterday. So it is a continuous documented quality assurance system, and it ensures that the products being produced are consistent with the one done during testing. So what are the key areas? So raw material, in-process control, finished products, equipment calibration, personal competence and documentation. These are the key areas which they monitors. And how it ensures? Firstly, the notified bodies.
2 more minutes.
Yeah, so I'll just go through. So this is one of the new product, emergency median opening barrier. So it is mechanically operated lockable section. So it allows emergency passage in terms of accidents, diversions. This is how it looks. Now going forward to the material traceability, with the new guidelines of government, we are required to emboss each product, but while galvanizing, the zinc deposits in the embossing and makes it unreadable. So we propose using a QR code which not only gives the product info but all other information which we are doing in the embossing. So this is how it looks. It gives each information and installation manual. So beyond that, it can also be used in case, as a smart node. So when it is scanned by any road user, it will give the nearest hospitals and trauma centers, police station like this. I'll show you a video, brief video, and you scan it. So I'll just move forward because I have a limited time. So moving on to the lighting solutions, we are also India's largest lighting mast and street light poles manufacturer. So this new product is called Zip Pole. It's a safer and softer approach. So now imagine a vehicle hitting a light pole. What do you imagine what will happen? The vehicle will be smashed, pole might injure anybody in nearby. But Zip Pole performs very differently. These zip poles are breakaway, energy absorbing, and they are designed to minimize the injury risk during vehicle impacts.
We are out of time, sir. We are out of time.
Just single slide, sir. So this is how the zip pole performs. If you want to see these products, come visit at our stall. Thank you.
Thank you. Four presentations to go. May I now invite Shri Kasturi Srinivas from Messrs. Bentley Systems India Limited for his talk on integrated beam approach for road design.
Good evening, everyone. Thank you, Chairman, sir. So I'm probably the odd man out because I'm the only software guy present here. I represent Bentley Systems. So basically, we are an infrastructure software company providing solution for entire road life cycle. So let me just give a little bit of introduction about Bentley. As I mentioned, we have solutions, software solution from entire life cycle, right from planning to the design to construction to the operation maintenance. So starting from the travel demand estimation to the conceptual design to a detailed design, bridge design, geological, modeling, geotechnical design. Pretty much we cover every, discipline of engineering so that you can actually design well and of course construct well in terms of monitor the construction pretty well in terms of managing construction, progress monitoring in terms of 4D and 5D and things like that. And then we'd have very good operations and maintenance solutions. So I think one of the major USP for our solutions is we have the ability to manage varieties of data right from the subsurface information like geological information, the GIS information, imageries, the engineering data, BIM data, sensor information, and the reality data as well. Will all get combined together in a single platform so that actually you can appreciate and come up with the better designs and of course construct it well. That's about a little bit about Bentley. Again, just to set a little bit more about context. So today's the project delivery is pretty complex. In fact, the example I chose is specifically from the tunnel infrastructure point of view. The many disciplines of engineering, many set of people need to sit and work together, make sure that the project gets constructed. They are interdependent. If there is any change made in one discipline, engineering has a ripple effect in other engineering as well. So again, the delivery is complex, and at the same time, if you look at it from a procurement point of view, there are many stakeholders. It could be owner operator, the contractors, consultants, safety, proof, the many parts of the life cycle in the project delivery involved. So again, there's about complexity in terms of making sure that everybody has the right information at the right time so that the coordination, collaboration basically, happens well. Again, if you go a little bit more, expand further into if we talk about current workflows, especially in the road design engineering, I remember, I used to, probably 20 years back when we started, we always had 3D models, when we were designing in 3D, but again, we dump it down to 2D and then give it to construction in the appraisal phase and construction phase again, O&M again, they're all moving to 2D drawings basically. I think with the advent of technology available, what we are actually, there are better ways to do it. Obviously, there are different, challenges, the quality of the DPRs, having a dynamic construction program, data-driven approach for the extension of time, or change of scope and things like that. There are many types of needs are there. I think what we suggest is that a better way or a BIM-based way to look at it where you basically design in 3D, and also the appraisal also happens in 3 dimensions, in the sense that you have a BIM model, the appraisal actually goes through the process so that you have a DPR cell which basically approves those models. At the same time, that goes for the construction phase. In that construction phase, before even bidding stage itself, all the contractors will have access to all these 3D models so that they can better appreciate the design suggested by the DPR consultant, and they can basically perhaps bid well, and at the end of the day, and construct it well as well. Again, the idea behind is that during construction, we're talking about having additional dimensions like schedule, time and dimension, again, the cost dimension, things like that. Again, you basically what you're talking about a unified approach so that you have a everybody comes together so that everything, you have effective project management and make everything easier. Again, in terms of the benefits, obviously, I've listed down here, varieties of benefits to the contractors. You have a better, evidence-based cost, change of scope or AUT. You can ask for owner-operators. There are many benefits because you have a design validation, you have a single source of truth, there is again evidence-based. So many benefits, basically, we can list it out in detail. Having a unified approach so that you can actually develop projects, effectively. Again, talking about how we do it, basically. So again, as I mentioned to you, we have very many design solutions. Having said, so what we are actually now is actually giving you an access, what we call a, Bentley Infrastructure Cloud, which is essentially a cloud-based platform. It simply works on a browser, and all you need is simple browser, basically, and then you can actually look at and appreciate varieties of information, whether that is a GIS information, satellite imagery, background like Google Maps and things like that, and the BIM models. And then you have the instant information will be available, and as you navigate the model, in a simple browser interface, you can turn on, turn off the different various layers, so you can basically appreciate the data and then come up with better designs. This again, simply looking at the data appreciation, but again, once a design has been completed and been given for, send it for approval or validation, again, same simple browser, you can basically open the model and do a simple cross sections and take measurements and annotate it well.
2 more minutes,
making
sir.
sure that, the design comes up, pretty well. Again, you can do the long sections, etc. All those comes, within pretty well in the same, interface, basically. Very, very easy to use, simple to use, and then you can also check the, for example, you might want to check the, sufficient clearance are available or not. Again, you can instantly check the availability of the clearances. Again, come back with the change measures. It can be done clearly. Again, I'm just giving you, rushing through a lot of information which I'm trying to give it to you here. Again, the another, facet about is that you can also look at the clash detection, because you can actually create a cluster of clashes and you can actually look at them and navigate them, making sure that those clashes basically addressed well, and so that you can look at them and appreciate them, and then make sure that your designs basically gets corrected and you can raise issues and things like that. At the same time, what you can also do is that you can link back the schedules, your project management schedules, link back to those 3D BIM models, so that you can actually plan well in terms of the scheduling. You can actually monitor the construction well in terms of progress of construction, things like that. So there are many aspects basically from the construction monitoring point of view also you can do it. Again, you can create a specific amount of views. Again, as you can see it on the screen here, everything is basically geospatially linked. All the Google information, Google realistic model is also available for you to come up with better designs again. So finally, I would want to show you one small example here is that, one of my colleagues built here, which is basically an example which he, I think it's...
Sir, we are running out of time.
Yes, sir. I think I have ran out of the, this PowerPoint also blocked, actually, it's not working. Hang ho gaya. Let me restart. Just about 1 minute, sir. Let me restart the here. Okay? So this is actually an example. Can you put it on the screen? Okay. This is an example, we built it for literally for a public consultation, for some very senior member of parliament wanted to see how does the construction which is being proposed is actually going to look like, and whether that is basically an approvable or not. So basically looking at a location near, Patna, they're trying to replace an existing bridge and then, come up with various a complicated industries being proposed here. Again, this is a very, very interesting example where a BIM model has been utilized to do come up with for a better public consultation. Again, since we are in Odisha, we built a road asset management for Odisha Works Department. We've been running this for the last 12 years. And then, which is a very interesting example where we built, inventory, payment management, road information, bridge management, everything is actually been all combined together for a road prioritization in terms of the maintenance and things like that. Again, finally, my
Sir,
last slide.
Please conclude, sir.
Yes, sir. Just one last slide, sir. So now we have, just to make it easier, we actually create a very simple package solution for road design, bridge design, tunnel design, your drainage. It's all combined. We actually launched a new combination called Sail Work Suite. And then if you want to understand a little bit more about it, please come to our stall. And then we have a lot of our experts are available for more discussions. I know I give a lot of information, but again, please visit us to give you more information. Thank you.
Thank you so much. Thank you. Although we would have loved to hear more about your systems, but with the paucity of time, may I now invite from Mrs. Vishwa Samudra Engineering Private Limited, Shri Nagendra Muli. There will be only one speaker, sir, or two? One speaker. The subject is role of commercial chemical stabilizers and significance of stabilization in pavement construction.
Good evening, everyone. Myself, Nagendra, and will be presenting on role of commercial chemical stabilizers, in particularly with respect to soil stabilization and full depth reclamation. Coming to soil stabilization, this is where we use locally available soils in the base layer, stabilized with cement and silica-rich additive, which is named as stable road. And second wing is full depth reclamation or recycling, where we use distressed pavement material. Again, the process is same in both the cases. This is purely in situ. The additive is stable road, which is manufactured in Germany, and this is purely made of natural minerals and has been used across the world more than 2 decades. Why stabilization? Main motive is to minimize the usage of virgin aggregates. We can use local available materials or the distressed pavement material. And the process being fully mechanized, we can assure best quality controls. And the process is pretty much speedy. We can do a lane kilometer in a day. And of course, the sustainability of strength with respect to time is another important parameter which makes it more suitable. And it can be adapted in wide variety of climatic conditions. This has been tested, and a lot of research has been done by various IITs and CRRI, and IRC has accredited this product. Straightly coming to the role of additive, particularly the stable road additive. there are 4 parameters by which the usage of additive can be appreciated. One being unconfined compressive strength, second is durability, third being sorptivity, and fourth is chemical resistance. So what happens when we use the additive in the soil cement matrix? The left picture represent only with cement and right being with cement plus additive. There will be a formation of secondary CSH gels which will refine the pore and densify the matrix, which will improve the mechanical integrity of the matrix and of course the strength and durability. This has been proven by XRD analysis as well, the red with cement and additive, the blue with only cement. Their peaks are enhanced due to the silica-rich additive. And the enhancement in UCS was clearly observed, and the 7-day UCS enhanced by 32% by usage of the additive. And for 28 days, it is 45%. And the beauty is the improvement in the durability, not only strength, with respect to the weathering actions, sustaining the strength is more important in cement stabilized or stabilized bases. So with the usage of additive, the weight loss gradually reduced by 75% due to the usage of this additive, complying with the IRC guidelines. And one more property is sorptivity. So there has been reduction in the absorption of the water, which has been proven by Rishi, conducted at IIT Roorkee. And of course, the chemical resistance has been proven with RCPT results. Again, this has been published by Rishi. And a lot of projects has been implemented or executed with this technology by Viswasamudra Engineering, and this has been done at ports and for runways at Hyderabad International Airport and national highways, state highways, city roads and rural roads as well. As of now, almost 952 lane kilometers has been executed with this technology. And this is a case study where it has been designed for more than 250 MSA at Krishnapatnam port. This has been studied by CRRI and IIT Hyderabad as well over a period of time. You can see the course in the right side picture. And this is the beauty where the strength has been enhanced or improved with respect to time against to the conventional pavements where we can see the deterioration of strength. And these are some of the execution pictures at International Airport for main runway in Hyderabad. This is again one more strength parameter. In generally for conventional pavements, it would be around 71, which is the design PCN, pavement classification number. With the execution of this technology, it was 118, much more enhanced. This one more road in Kerala, which has been performance evaluated by IIT Hyderabad. And one more road in Andaman. This has been proven that sustaining very huge rainfall for more than 6 months without any distresses observed. And this is one of the Morth project in Bihar. You can see the right side picture where road was under submergence for more than 2 months. And government officials has visited and extracted a core. You can see the right side picture, the sustainability of core even after submergence for 2 months. This one more road, in, city road in Hyderabad. And these are a few more pictures of rural roads in Andhra Pradesh. And again in Uttar Pradesh for Rural Road Development Authority, where this technology has been implemented for more than 300 lane kilometers. These are the cores. And this is the finished road. Yeah, this is an exciting picture. So generally in conventional pavement, what happens is if there is any drainage issue or any flush out of water in the subgrade, the entire pavement might be subjected to immediate damage, causing obstruction to the traffic. Yes, I will conclude. So that is not the case here. which will avoid immediate failures. So you can see the subgrade and subbase washed out. Stabilized base with stable load additive has sustained. And this gist of projects with respect to the strength parameters and aggregate resource savings, as of now what we have achieved. And this is in line with our Honorable Prime Minister's vision of net zero carbon emissions by 2070. As of now, we have saved 42,000 tons of carbon emissions, which accounts for 83,000 trucks of aggregates, fresh aggregates. With this, I will conclude. You may visit our stall at number 44 for any further information.
Thank you. Thank you. May I now quickly invite Mr. Ashutosh Kumar of Messrs. Eurotech India Private Limited for his talk on road bridge transition slab re-support and georesin subgrade compaction.
Thank you, sir. Namaste, everyone. My name is Ashutosh Kumar. Today, I am representing Eurotech India Private Limited. Actually, हमारे पास टाइम लिमिटेशन है, सो मैं डायरेक्ट पॉइंट पे आना चाहूँगा कि हम वाकई में मार्केट में क्या करते हैं एंड हम लोग क्या कर सकते हैं। यहाँ बैठे हम सभी ने कभी ना कभी अपनी लाइफ में ये ज़रूर एक्सपीरियंस किया होगा कि जब भी आप किसी हाईवे से होके गुजरते हो, तो जब भी आप किसी अप्रोच स्लैब या किसी ब्रिज से होके गुजरते हो, आपको सडनली एक बम्प फील होता होगा। इन दैट लोकेशन हमें क्या होता है, ये जो प्रॉब्लम है वर्ल्ड वाइड इशू है। सो मोर देन 50 कंट्रीज़ में यूरोटेक वर्ल्ड वाइड सेम चीज़ में काम कर रही है। इंडिया में बेसिकली क्या होता है, हम क्या करते हैं, वैसे सेटलमेंट्स में हम लोग बिटुमिन का ओवरलेइंग करते हैं। सो दैट ओवरलेइंग इज़ नॉट ए परमानेंट सॉल्यूशन। यूरोटेक हैज़ दैट परमानेंट सॉल्यूशन दैट हमारे पास एक्सपेंशन जियोरेजिन्स केमिकल्स है, जिसको हम लोग -6 to 7 मीटर इंजेक्ट करते हैं। वी कॉम्पैक्ट दैट we can compact the subgrade sub base up to -6 to 7 meter, and it is a permanent solution for lifetime, one time solution. So we are working in airports, industries, rail and roads. In we have actually हमारे पास एक 2 type of component chemicals injection हमारे पास है। ये बिना किसी क्लाइंट इंटरप्शन के, बिना किसी प्रॉब्लम्स के, बिना किसी डेमोन्स्ट्रेशन के, बिना किसी डिसमेंटलिंग के हम लोग इंजेक्ट करते हैं एंड वी कैन इजीली लिफ्ट एनी काइंड ऑफ स्लैब। दैट केमिकल लोड बेयरिंग कैपेसिटी इज 30 to 40 टन। सो हम लोग किसी भी प्रकार के स्लैब को लिफ्ट कर सकते हैं, स्टेबलाइज कर सकते हैं। एनी काइंड ऑफ फाउंडेशन वी कैन लिफ्ट एंड वी कैन रीलेवल दैट। We have inject expanding polymer. नॉर्मली आपने देखा होगा जो भी ब्रिजेस में है, अप्रोच स्लैब्स में है, सेटलमेंट्स की वजह से हम लोग करेंटली वहाँ बिटुमिन लेयर बाय लेयर टाइम टू टाइम बिटुमिन लेयरिंग करते रहते हैं। बट दिस इज नॉट ए परमानेंट सॉल्यूशन। वी कैन टू फाइंड आउट दैट स्टार्टा, एक्चुअली नॉर्मली हम लोग नहीं कह सकते कि कौन से स्टार्टा में वो सॉफ्ट सॉइल है या फिर कैविटी है। सो उसको फाइंड आउट करने के लिए हम लोग एक टेस्ट परफॉर्म करते हैं, दैट इज कॉल्ड डीसीपी टेस्ट, डायनामिक कॉन पेनिट्रोमीटर टेस्ट। इट इज परफॉर्म फ्रॉम टॉप टू -7 to 8 मीटर टू फाइंड आउट द एग्जैक्ट सॉइल strength. You can see in this video, this is pre-injection, pre-PU injection. You can see in this video that बिना किसी प्रेशर से डायरेक्ट रॉड मेरे अंदर चला जा रहा है। दैट मीन्स इन दैट लेयर द सॉइल इज वेरी वीक एंड वेरी सॉफ्ट। सो दैट वी हैव ए रिजल्ट दैट इज कॉल्ड डीसीपी रिजल्ट। ये जो ग्रीन आप देख रहे हो, that is all zero. That means without किसी pressure के जो हमारा rod है, this is N values जो बिल्कुल zero था. After injection, that blue line is post injection. So around 800 to 700 times the load bearing capacity increases. And this is the post injection video. You can see. That load bearing capacity increases after the injection grouting we perform. So कभी कभी क्या होता है, जैसे रोड के नीचे से कोई भी आपका ड्रेन लाइन जा रही है, यदि उसमें किसी प्रकार का लीकेज हो तो उससे क्या होता है कि टॉप से पॉट होल्स का डेवलपमेंट होता है और जिसकी वजह से सडन रोड क्लैप्स हो जाता है. इवन we can seal that pipe as well. ये आप देख सकते हैं पिक्चर में जो पॉट होल है, ये सॉइल के कोलैप्स की वजह से हुआ है, तो इसको भी हम लोग रेक्टिफाई कर सकते हैं. Okay, thank you.
Thank you for saving our 2 minutes and for an excellent presentation on georesin subgrade compaction. Now we come to the last presentation of this session from Mrs. Jindal Stainless Limited. I invite Shri Arun for his talk on stainless steel for maintenance-free and ultra-durable bridges.
Full screen, full screen.
Very good evening, everyone. So I represent the Jindal Stainless, part of the Jindal Group, and here I am here to talk about maintenance-free solution via stainless steel. From time non-existent, corrosion has been a problem in steel. So the only way to counter it these days has been to give protective coatings. However, stainless steel is a material which can take care of itself due to its corrosion-resistant properties. We are building now stainless steel bridge girders as well as stainless steel reinforcement. My discussion will be in relevance to this. And the classic example here is the Eiffel Tower and the Chrysler building. Both have served 100 years without undergoing any sort of corrosion. In the Chrysler building, only twice. The corrosion-resistant properties due to the presence of 10.5% chromium in stainless steel. This forms a thin layer of 2 nanometer, which takes care of itself and is responsible for the corrosion-resistant property. There are multiple grades. You can pick and choose based upon the service life requirements. If you want a bridge for 500 years, you can pick a grade. If you want something for 120 years, you can choose a grade. These are having comparable properties to E350 and E450 in terms of Young's modulus, proof stress, ultimate stress, percentage elongation. And you would also notice there is a different parameter here, the pitting resistance empirical number. This shows the relative corrosion resistance of a material. And the graph shows the stress strain curve, also the moment carrying capacity. Usually in steel, there is a thickness loss that happens with time, which reduces the moment carrying capacity. But in stainless steel, this doesn't happen. Also, the fatigue performance, which can be seen by these graphs, the SN curve shows that stainless steel performs better in 2 × 10⁵ cycles. Most of the mechanical properties, basically stainless steel has 4 families: ferritics, austenitics, and the duplexes. As you can see, the ferritic shares most of its properties with steel. You can see Young's modulus, Poisson's ratio, everything are almost the same, the density also. Where it changes is with respect to the thermal coefficient of expansion and thermal conductivity. So these have to be accounted for in designs. The question in your mind is, what about connections? Stainless steel preloaded bolts are available, HSFG bolts are available, shear studs are also available in the market. There are design standards available internationally, DC 27, Eurocode 1993. IRC B5 committee is also formed for creating a stainless steel composite girder. There is an IS committee for structural grade design equivalent to IS 800, and IS 2062 are also in formulation. This is stainless steel IRS 350 CR and 450 CR incorporated in 6911, the code. As you can see, this map shows the stainless steel projects that are available and happening in and around India. This is the one of the kind first stainless steel pylon for a cable stay bridge. There are 3 pylons, 62 meters in height, made out of 70 mm plates, 3.5 mm meters boxes of height, and internal stiffness of 40 mm. This will be the world first. This is currently under construction, as you can see here. This is another completed project, skew bridge of 22 degrees, Parekh Nagar, 41 meters span and 21 meters wide, vehicular bridge. Also, this is built with duplex. The service life expectation for this bridge is 500 years in a deeply polluted environment. And this is in service for the past 3 years. Not only big bridges, small composite bridges have also been made in deeply congested areas in Mumbai across nalas. And not only bridges, buildings have also been made in stainless steel. 316 grade stainless steel, 316 grade stainless steel has been used for the United India Assurance building at Chennai, opposite to Satyam Theatre. This is an upcoming project. I would skip the video for the time constraints, but will be a sea-facing bridge, completely cantilevered. The diameter of this bridge is somewhere around 300 meters, and it will be a cable-stayed bridge coming up in Kerala. Also, this is across Buckingham Canal, one of the most polluted canals in Tamil Nadu, and this will also be coming up in stainless steel. So the idea here is, when you are looking for structures which have to perform the test of time, you go for stainless steel. We can't be building our infrastructure again and again for the sake of building it. You need something sustainable, recyclable, and which can serve the test of time. Please do consider stainless steel. Yes, it is a premium product, but the initial cost increases, but we trump in life cycle costs. The life expectancy increases, everything increases. Now moving on to the second part of my presentation. I have 2 minutes more. Yes, sir, I'm noting my time. I'll be on time. Stainless steel reinforcement is available. They have used it in whichever projects have required highest life, be it mandirs, be it hostels, etc. The enemies of concrete are carbonation and chloride attacks. This stainless steel guy can perform better. The critical chloride threshold value for stainless steel is 4 times better. The corrosion mechanism is due to carbonation. You can do it by phenolphthalein testing. When the pH drops down to 6 or 8, it becomes chemically active. So stainless steel can perform better. The volumetric expansion of steel reinforcement would cause spoiling, but that is not the case in stainless steel reinforcement. These are the different cracks on the pathways that will inevitably happen in your structures. No matter what you do, you modify the chemistry of concrete, it will deteriorate. So you need a material which can take care of itself. Okay, you're thinking about, what about standards, boss? You have 16651. There are a total of, chemistry-wise, there are a total of 7 grades. We can pick and choose. You can come to our stall. We can discuss in detail about the chemistry and stuff. The mechanical properties are comparable and even better We call our reinforcement as SS550 and SS500. We don't have a D variant. I have 30 seconds more. There are NHAI policies as well as railway policies available. And that's all. Good night. Pleasure meeting
Thank
you all.
you. Thank you. So now is the time for any questions. Actually, there should be a prize for remembering who said what. In one session, I have never seen 13 presentations, but we did today. And any questions? Yeah, yes, please. I think you have to give the mic.
In the last presentation, it is pressed about use of stainless steel, but what is the percentage increase of cost if we use normal river? Then in respect of normal rivers, if you use the stainless steel, what will be the increase of cost?
Based upon the type of bridge, I would say the initial cost of the project would go up by 20, 25, 30%. But life cycle cost, we would be at least 300 times better than that of normal steel. And IBMS, International Bridge Management Systems, Indian Bridge Management Systems, our design requirements for bridges are 120 years. Our average life of a bridge in India is somewhere around 45 years. We can take it to 120 years, so please do consider stainless steel.
And regarding Uritex, they told that one type of chemical is to be used for densifying the soil. What is the material? I could not understand. Please explain.
Sir, that is called georesins. We have two type of component. One is Urotec resin, another is Urotec hardener. So after mixing of this, it has some expansion property around 20 to 3 times it's expanded. And it has load bearing capacity around 30 to 40 ton per square meter.
Is there any impact on the groundwater?
Actually, it is a hydrophobic material, sir. So there is no any disturbance with, no any mixing with water, sir. It is totally plastic material.
And in super arch, I have a humble question that during lifting, it is made by PCC. Material is PCC, but during lifting, shape is changed to get a parabolic shape. Can a PCC member change its shapes like rubber or anything flexible material? Please explain this.
Actually, sir, this is expansing material. So we can lift any kind of slab, any kind of foundation, any kind of concrete slab foundation. So what we do, if just an example, if we have a slab, like 200 mm slab we have, and we found that in just below the slab there is a cavity, so we just do a minor hole, 12 mm drill holes we do.
Sorry. My question is to different person who presented regarding construction of arches.
Arch bridges.
Sorry.
Okay.
Sorry. Name of the company is Power Arch.
Power Arch. Somebody from Power Arch is there, no?
The material you told that it is PCC, but during lifting, it changes its shape from...
Yes, those blocks are made up of PCC, but those blocks are connected with some material, and that material is flexible. So there are individual blocks which are connected to each other, and then they convert into the arch. So it is not like a one member. It's a combination of different members stitched together. When it is lifted, it becomes arch.
But it is staged by which material? It is without any reinforcement. You told that no reinforcement.
So please don't your mic here and there. I cannot hear clearly.
You told that no reinforcement is required, but how it will be stitched? That blocks are stitched by which material?
What he's asking is how the blocks are stitched. How the blocks are stitched.
Okay, these blocks are stitched using, there are 3 different methods. One is with the polymer, one is with the wire rope, one is with the steel fixtures. It depends on the size, span, rise of the arch, what material we'll use. But all these materials are temporary materials. Once we lift the arch, we remove all the material from there. That arch itself doesn't require any kind of reinforcement.
Okay.
That is temporary stitching.
Okay.
Yeah?
But the segments are also stitched side by side. By which material it was stitched?
Yes,
By
that
cast
depends
density
on the
concrete?
design requirement of the structure. If it is an underground structure like a tunnel or the portal or the cut and fill tunnel, then we have to stitch it. For the bridge, we doesn't require that.
Okay.
Yeah.
Thank you.
Thank you.
Thank you. Thank you.
Excuse me, my question relates to use of stainless steel in bridges. Now, as per IRC codes, specifically IRC 112, what we see is that there is allowed, we can use stainless steel in non-structural components. But it is not actually specifically mentioned that we can use stainless steel in structural components of the bridge in IRC 112. How do we address the design issues corresponding to the IRC codes? That is my question.
Beautiful question, sir. This has been amended out in IRC 112-2020. This is for structural applications. Your questions on top of your mind are, both, what about the bond strength? The bond strength of stainless steel reinforcement is on par with that of carbon steel reinforcement. Okay, that is doubt number one. Doubt number two is, what about the proof stress as well as the ultimate tensile stress? In carbon steel also you have Fe 550, we have SS 550. You have Fe 550D, we have SS 550, because D stands for ductility. Stainless steel is naturally more ductile than carbon steel. Also, the lap length would be the same. The development length, everything would be the same. The design also would be the same. Internationally, cover thickness reduction is possible. IRC codes are currently conservative to the extent of you can reduce the cover thickness to 10 mm. But we are expecting a sea of change in coming years. I have presently just made presentations to various stakeholders saying that the critical chloride threshold values of required for corrosion initiation in stainless steel reinforcement is 4 times that of carbon steel, sir. So the time it takes to initiate corrosion would be 4 times lower. We can meet and discuss in our stall also, sir.
That is okay. That is the inherent property of stainless steel,
Yes,
not to get rusted. That's fine.
Yes,
but
sir.
now a general question is that I had heard that IRC has been contemplating to constitute a committee on stainless steel, use of structural stainless steel in steel bridges. So do you know any progress about that, whether that
Sir,
code or draft code has been published or
3
not?
days before I was in the 4th IRC B5 meeting for structural code for composite girders, sir. Also, RDSO has already uploaded stainless steel footover bridges design in the website. RDSO will pretty soon be uploading various other spans as well. They have taken it to task. IRC is also looking at coming up with a standard by the end of this year, sir. It will be
Okay, thank you.
Thank you. There was one question from this side. Yeah.
I have one small question from Eurotech. You had shown, I think, Delhi Eastern Peripheral. In that you were doing some grouting work in which the path hole and the lower section of the roads came on the same level. And you showed some pictures and told that if the bridge or the bridge foundations goes down, pier goes down, then the same can be lifted. Am I correct?
That not pier, sir. That is transition slab or departure slab.
Okay. So if my question is, if the pier and the pier foundations, due to sedimentation or due to corrosion of removal of the sand, it goes down by say 1.5 meter, 1.6 meter or 1 meter, which has happened at several places. So can that effect be mitigated with only injecting your chemical?
Actually, sir, our chemical load bearing capacity is 30 to 40 ton per square meter. So any kind of load under this, so we can relabel that one and we can stabilize that to prevent further future settlements.
My question was not about stabilization. My question was simple, that can it be lifted to the same position?
Yes, it
or
can
no?
be. It can
Okay.
be 100%.
Now, when you have lifted this pier, or the pier cap is on the same level of the behind and the next one, will there be any difference in the bearing used in the superstructure and substructure, or any work needed in bearing?
Actually, sir, we have a controlled, we have a controlled injection policy. So during the lifting, we put many laser machines beside all piers, beside the slabs, that if there is a slab which has no any settlements, so we do not want to overlift that one. So it is a totally controlled, which column or which foundation you want to be lifted, we only lift that one. And in once, we do maximum lifting 10 mm, not like you have a settlements around 200 mm. We do not lift by once in 200 mm. By repeat injection, we do the repeat injection in same holes, 10 mm each, parallelly over all the foundation or over all the slab, then we relabel this.
How you manage to make the surface level uniform when the injection grouting is done?
Actually, the procedure is we started from the lower point. Before the injection, we do two things. One is the level survey, another is the DCP test, which I have shown you. So we do some pre-DCP test, and after injection, we do post-DCP test to know how much strength it increases. So your question is to how we manage the levels.
Correct.
So for that, we do, during the injection, in that duration, we complete monitoring that place, even where we are doing the injection or where we are not doing. And we started from the lowest point. If, like, I'm just saying an example for a slab, if a factory slab, it has a settlements in one portion is 150 mm, another is there is no any settlements. So we started from that 150 mm, and normally you can find that there is some average settlement is there. So we started from the below point. So once we lift that one 10 mm, 15 mm, then again we come to the another side and we lift that one 5 to 10 mm, then parallelly one by one repeat injection, we do that.
Thank you.
Thank you very much.
Thank you so much for your question.
Last question, please. Any other question is there? Hello.
My question is to Eurotech again. The injection that you're doing, does it have a creep?
Creep, that means, sir?
Like with passage of time, does it tend to settle?
Yeah, actually, sir, the chemical property, its longevity is more than 100 plus year. So this is just like a plastic material. So once we injected, and that time we need a maximum load on the top. Like if we are doing a lifting job in a factory, so we need that time the maximum load on the floor. So once we lifted, there will be some settlements that is up to 5 mm to 10 mm maximum. After that, there will be no any settlements.
Thank you, and no, please, no further questions to Eurotech. I think you can go to their stall and ask any other question for any other of the presenters.
My question is to Secura. You showed LCA calculation with geogrid and asphalt. So is that cradle to grave or cradle to gate?
Cradle to?
Cradle to gate or cradle to grave?
Can you simplify the question?
You showed a LCA calculation.
No, I have shown only the FWD part actually. I have compared the performance of the bituminous mixes reinforced with asphalt mixes to that of the mixes without reinforcement.
So one you used with geogrid.
Yeah.
So what are the factors we are taking for calculating the life cycle?
Here I have not calculated the life cycle, just I have compared the
Only
fatigue,
the durability.
only the fatigue performance. So if I am using the glass grid, whether my fatigue performance is improving or not, moreover, along with the fatigue performance, it is also helpful to delay the reflective cracking. Only those two parameters were checked in that. Because life cycle cost analysis, actually we are comparing, because it was only 2 years payment, we need to see the performance of the payment over a period of time.
So that portion has not been done.
No, that we haven't done. We will be doing it.
Okay. Thank you.
Thank you. I think we should conclude this session now. I would now request my co-chair for his remarks.
I thanks all the participants and presenters. I thank you all the presenters and participants who have listened carefully, and all the presentations are excellent. Thank you.
Thank you, sir, for your very short and all-encompassing remarks. I also congratulate all the participants, all the delegates who are here, and all the presenters for covering a plethora of aspects of road construction and bridge construction. With that, we come to the close of this session. Thank you.
Sure. Thank you so much, session of the chair and co-chair, and of course all the representatives. Requesting everybody to please stay back with us for a few more minutes. Now it's time to felicitate all our respected representatives. So I would like to request the chair of the session, Shri D. Roy Chaudhary sir, is going to give memento to Tata Steel Limited. Can we have Tata Steel Limited? I need some clap from the audience. The next memento is for Reblock Concrete Barriers, Safety First. The next memento is for Honeywell International. Next is Tikitar and Cell India Private Limited. Can we have Mokaferi Environmental Solution Private Limited? Next, I would like to step forward, Powered Arc Innovation Private Limited, Nagpur. Well, the next memento is for Jal Nidhi Bitumen Specialist Private Limited. So our respected co-chair, Sri P.R. Chandak sir, is going to felicitate. The next representative would like to come forward is Sikura India Private Management Limited. Next is Utkarsh India Private Limited. Can we have Utkarsh India Private Limited to step forward and receiving the memento? And the next felicitation goes to Bentley System India Private Limited. Next is Vishwasamudra Engineering Private Limited. Requesting everybody to please give a big round of applause. Next is Uritech India Private Limited. And the next memento for our representative of Jindal Stainless Limited, New Delhi. Along with that, would like to request on stage Engineer Trinath Behera, Additional Chief Engineer, Works Department, Government of Odisha, to please come on the dais and felicitate the chairman of the session and the co-chairman of the session. First of all, would like to thank you and welcome Shri R.D. Roy Chaudhary, sir. Thank you so much, sir, for all your valuable time. Next, would like to request our co-chair of the session, Shri P.R. Chandak, sir. Thank you so much, sir. So we are winding up the technical session 5 here. So thank you so much, all the representatives. Thank you so much, our respected chairman and co-chairman. Thank you so much. Well, we have the cultural programs going there. You can go and enjoy. Thank you so much.